Зал протестируйте звук, пожалуйста.
when skies are high. Where the very air is thick with history. Of the past meet the dawn of the future. A place where vision is molded into substance.
So actually, the morning of the second day is the most difficult actually morning because of the last evening. But I hope you survived and alive. So and those who are watching us on stream, so for them, so we are open in the three platforms. So Telegram, VK, and YouTube. So today also a very condensed day, which actually combined lightning talks and sessions, and of course our headliner. Who will be introduced by our chairman of the second plenary session. And by the way, I should say that you may already download proceedings, electronic version of proceedings, which is on the blue button on the website. And now, so I think it's time to start our second plenary session. Well, and the chairman of the session is Professor Vasily Kovalyev, who is a ex-head, but now is a senior, researcher of the biomedical laboratory in United Institute for Informatics Problems. Okay. Yeah.
Okay. Good morning, ladies and gentlemen. It's my pleasure to introduce today the very first talk about artificial intelligence problem, Sergei Markov. And you see on our website, and you read, I'm pretty sure, many times, his biography, his achievements in different branches, and not only theoretical, but also very extensive practical applications. To me, chess game is something special, which is not very often we can see in that kind of biography. And in my view, recently, we see just kind of revolution which is going on in IT industry and in general and artificial intelligence in particular. And I think, and not only me, of course, many people believe that getting the better achievements of a traditional, let's say this way, or general artificial intelligence or artificial general, as now it's abbreviated for, and try to incorporate very good achievements for many years of development of this basic, very exciting direction to recent achievements, to recent technical possibilities, which provided by supercomputing and parallel computer and convolutional neural network and all this stuff, including large language models. And that boom should be somehow boiled to get very, very nice borscht. What is kind of soup, if somebody don't know really. So now it's time to present the results. Please, floor is yours. Take the place you like.
Thank you very much for the introduction and hello to everyone. So my speech today is about the artificial intelligence, but you know that some basics should be said before, because you know, when you meet ordinary Plenary people and you ask them about artificial intelligence, their views on artificial intelligence is based not on works by John McCarthy, or Alan Turing. Usually they just seen several Hollywood movies and their views of artificial intelligence is based on those movies, from the ancient times, red-bearded guys started their discussions with the definition of terms, so we should define what is artificial intelligence for us and during this speech. And artificial intelligence actually is a field of science and technology that works on automatizing of solving of different intellectual tasks. So if we have some tasks that could be solved by a human brain and we are creating some tool that will help us to solve such a task or maybe sometimes replace human when solving such a task, this is artificial intelligence. So I think it's a very typical solution from our species how to deal with some limits of our biology. We don't have something like sharp teeth and like something like sharp claws, but we have created swords and knives, and of course we don't have something like fur or maybe a thick skin. Same thing. It's like we have some limitations of our biological intelligence, and so we should create some tools to extend the limits of human intelligence. So inside the area of artificial intelligence, there are two sides. So the first one is narrow artificial intelligence, which is focused on solving several particular tasks. The narrow AI systems are successful because of their very big specialization. It's like, Deep Blue chess computer that is able to play chess better than best humans in the world, but it could not recognize cats on images, and also it couldn't play poker. It also couldn't play chess on a 9-to-9 board. Only standard 8-to-8 board, and the logic is wired deep inside computer chips of Deep Blue. So it is very efficient just because it's very specialized. In nature there are several organisms that are that has very small nervous system, but they could solve several tasks better than us. It's like be able to find the optimal road inside the beehive better than we could do it. But our brain consists of 86 billion neurons, but the bee's brain is smaller than 1 million neurons. So, but due to higher specialization, those bees could do something better than us. So the narrow AI systems are efficient due to their specialization. But the other artificial intelligence is hypothetical artificial general intelligence systems. I would say something more about artificial general intelligence, but let's start with some very simple definition that artificial general intelligence is systems that are able to solve any tasks that a human could solve. So it's something like that. It's very I think very simplified definition, and it was invented just to point the direction, so we will discuss it a bit later. This is the original definition of artificial general intelligence from 1997. Mark Gubrod invented those terms, and now we are using a really simplified version of the original definition. Anyway, this is very widely disputed through the literature. Artificial general intelligence is an intelligence capable of performing any intellectual task a human can do. Anyway, we have problems with such a definition because
almost every part of this definition is very questionable. For example, for which human? Maybe for expert, maybe for some statistically average people, or maybe we have some tasks that could be solved by only one man in the world. Does it mean that we should include it into benchmark or not? The second question is within which time, energy, and value limit, because it's really simple to write a chess program that play ideal chess. It's just a full search of the game tree. So we create a full searcher, and it will guarantee the best move every time. But practically, it will spend billions of years to find the best move in average position. So that's the problem. Maybe some system that could solve any actual tasks, but spending all time until the end of universe. Is it okay? Is it artificial general intelligence or no? What does it mean to succeed? Because, in the case of some simple mathematical equations, it's really easy to check the right solution. But in the case of some generative tasks like poetry or painting or something like that, what success in such a tasks? How to measure it? Are 100% of tasks important? Maybe some tasks are not very important practically, but so formally the system that will not be able to solve such problems who named artificial general intelligence. And it's really hard to transform such a definition into definition of done. How to check that we are already created artificial general intelligence. And there are some different problems of these definitions, like focus on human replacement or some weak connection to practice and so on. So practically, it is a result of the definition wasn't in the times when every artificial intelligence systems was very narrow. And now when we have much more general systems like ChatGPT or something like that, we are really in need of some definition of done. And that's a problem. So almost every lab tries to redefine artificial general intelligence because it's really important to be the first who will achieve the artificial general intelligence. So PRIP has one definition of artificial general intelligence, OpenAI have another definition, and so on and so on. So because they want to say we are first who create artificial general intelligence, because of some economic consequences. And I think that apotheosis of such a process as a definition that was used during the deal between OpenAI and Microsoft. They said that artificial general intelligence is a system that is able to earn $100 billion. And it reminds me of the book about The Little Prince by Antoine de Saint-Exupéry. It's about when a child said it's hard to describe how the house is beautiful for the adult, but when you say that this house costs 100 millions of liars, and the adult says, "Oh, how it's beautiful." Actually, of course, the big tech companies want future like that. Actually, when you say that you have some artificial general intelligence, everyone goes to you and buy such solution as you and buy such solution as a service. But to do it, you should proclaim that you have created artificial general intelligence. From our point of view, the better not trying to redefine artificial general intelligence term, just drop it. It's a very theoretical definition, very theoretical term to point the direction, but we need some much more clarified definitions, clarified goals. So from my point of view, it's something like practical artificial general intelligence. It's a way how to describe in very precise engineering terms what we are building and what problems we're trying to solve when creating such systems. And the purpose of AI and the purpose of our information technologies, it's augmenting the human mind, augmenting our intelligence. So it was very clear to the fathers of our area, like Douglas Engelbart, Apple and current interfaces that we are using every day based on the ideas of Douglas. Engelbart, so it's not only the inventor of computer mouse. And he wrote a very important work. It's a conceptual framework of augmenting human intelligence. And several ideas from those work are still very actual today. And Ed Fredkin, he said it in maybe some poetical way. He said we could advance all areas of science and art as partners in intellectual systems that complement and reinforce our correctable weaknesses and that make use of all our inherent creativity. With computable wings, we could soar to meet the phoenix. The ideas of some man-computer symbiosis was invented very early, so different works on those topics in the era of good old-fashioned artificial intelligence, you know. The term artificial intelligence was invented in 1955. At least it was the first time where this term appears in literature. So it was the proposal to organize an Dortmund conference. So it was very romantical times. I think it's like the beginning of space era, and you know, in the beginning of space era, it was. We all was very optimistic. It's like in 10 years we will fly to moon and we'll build the base, and then we'll fly to Mars, to other planets of our solar system, and maybe at the end of the millennia we will travel to the stars. It was a very typical view of those times, and the same for the artificial intelligence. You know, it's like it was not clear that the distance between the system that will beat the world champion in chess and artificial general intelligence will be so long. Because you know, chess is a very popular intellectual game. So if you could play chess, you are a very smart guy. So but you know, actually, to play chess and to solve any intellectual task, the difference between such is really huge. So we try to extend some limits of human mind, but which limits we have? It's not a context of such limits, but some of them. For example, speed. You know that the thing inside our skull usually. Some guys said it's better. You know, we have software, hardware, and wetware inside our skulls. But what does it mean wetware? Why it's so wet? It's because it's a chemical system. So the signals could be transferred between different brain cells through chemical pathways. So it's like we should push the ion through ion channel to transfer a signal from one neuron to another one. But the speed of such a transition is not very big. Why? Because to do it really fast, you need to have a big potential difference. But if the potential difference is bigger than 1.27 volts, it will result in breaking water in your brain into hydrogen and oxygen. And finally, it will result probably in some explosion. It will not help you to do some mental arithmetics. So that's why we are very limited in speed. The length of spike in human brain is limited to several milliseconds, so it's really a long period from the point of view of current electronic systems, for example. So the speed is one of the problems. Sometimes you need to solve some intellectual tasks very quickly. Also, reliability. If you lend some money to someone, you know that humans are not very reliable, so sometimes we need some more reliable system in a chain to replace human and make the whole system much more reliable. Limited parallelism. The problem of parallelism, of course, when we are trying to solve more than one problem at one time, we are doing it worse and worse. Communicative limitations. We have a very limited bandwidth of our sensory cortex. Maybe it would be great to watch 5 or 6 TV shows simultaneously, but we could not do it because of limitations of sensory cortex. Physical fragility. You know that our universe is not a very good place for us, so we need a very short range of oxygen concentrations, of accelerations, of temperature, and so. The percentage of volume of our universe in which we could exist is very, very small. So sometimes we need to solve some actual task outside of the cradle. Subject complexity limits. Some systems are very limited, it has very big complexity, and one human could not fit such complexity inside our understanding. So when analyzing biological systems or social systems, it could not be done by a single person. Of course, we're trying to solve it by creating some human collectives working on such systems, but the collectives limited by some parallelism limits, the Amdahl law, Gustafsson-Barsis law. So it practically means that when one builder could build the house in 1 year, and if you have, for example, 10 millions of builders, they could not build such a house in a few seconds. So that's a problem. Limited memory, of course, limited expert skills of the particular person. Motivation barrier, sometimes we just don't want to solve some intellectual task, but we should do it. And the last but not least, the scaling and the replication barriers. If you have, for example, if you need, for example, a call center with 100,000 of operators, it couldn't be built in 1 day. You just don't have time to employ such a number of people and teach them how to do it. And after you don't need it, you just could not downsize it easily. So, but you could create several millions of virtual servers to solve your task. So that's the solution here. So I have one simple question: what such a things has in common? Stone, bronze, and iron. Which idea is for those things? Yeah, of course, it's a human history. The human history is about taming of different substances. We started with stone, then we tame bronze, then iron, and finally built a foundry in Frankfurt on Main or something like that. Such an image of human history was invented in the beginning of 19th century, and it says much more the society of the beginning of 19th century, because, of course, it's really typical for humans to say that history leads us to this place. Just see the history through the glasses of the current moment. But before the Industrial Revolution, the most history books were started from the story of Adam and Eve and their living in paradise and so on. But after the secularization, the founding of authors of history books was changed from the church to some secular part of society that was, of course, based on industrial companies. And that today the biggest companies usually base their business on informational processing, not on steel processing. So that's why we could read the human history and say, of course, the stone, bronze, and iron are very important. But there was also very different ages in the human history. First was the era of vocal speech. So it was the times when the only way to transfer information from one individual to another, it was the speech. So, and then writing. Writing, of course, it's a very big revolution. So now your grandmother died, but your favorite cake still on it because you have written recipe, and you are able to write the recipe how to build house, how to make trade, how to solve some complex tasks, and then transfer those information from one people to another without need in personal contact. And then the printing. The printing resulted in much cheaper information distribution. It's about 100 times cheaper than writing. So it resulted in a big boom of information in our society. So before printing, the percentage of literate people was really small in our society, and the amount of books was very small, amount of information was very small, but printing was a revolution. And then the revolution of electronic communications and the particular World Wide Web. So it again makes the distribution of information much cheaper and faster, and of course allow us to make some automatic processing of information in something like Google is not possible without World Wide Web. So if you to perform a search in a big pile of information, it's only possible in the era of internet. And today we are probably inside a new big revolution, and this is dedicated to generative artificial intelligence. Because in current large language model, we could see the prototypes of some future systems that will be able to write a book for your query, just a query system to write a book about, I don't know what, plumber. And in a few minutes, such a system will write such a book, effectively projecting all the digital information in the world on your query. So before generative artificial intelligence, it was necessary to spend a lot of time to write a new book, to make some projection of currently existing information on your particular need. But in the era of artificial general intelligence, it would be able to create books that will be written during reading, and it completely transforms the whole informational metabolism of our society. So that's why it's a new revolution. It's a very open question how it will transform our society. Probably it will transform it a lot. So Jevons paradox, it's here. Probably because, of course, some people says we all will be replaced, because such a powerful technology will, of course, make some jobs obsolete. But there is a very, very good example. It's programming. That in the 40s, there was only 100 programmers in the world, and they does very strange things from our current point of view. They make some holes and punch cards. They used some computation panels to program the old computers, and there was an era of advances of information technologies from those times. It's the low-level programming languages, then high-level programming languages, then some shared libraries, then several social tools of development like Stack Overflow or GitHub, and so on. And now I think the productivity of each programmer is 100 times more than in 40s. So why don't we live in a world with only one programmer? Because now one programmer could do all work that was done by those 100 programmers. And of course, we are living in a world with not one programmer, not 100 programmers, but 100 million programmers probably. So why? And that's because it's not zero-sum game. The technology never was a zero-sum game. And from the economy point of view, it's a very typical thing, the Jevons paradox. When you're starting to use some resource much more efficiently than before, it finally results not in lower consumptions of such resources, but in wider consumption. So in the case of the programming, there was a lot of big industries created by informational technologies, so like gaming industry, and it created a lot of jobs for very different people, not only for programmers, but for designers, for managers, and so on and so on. So I think with artificial intelligence, it will do the very same way. So we're trying to create other tools for now. So the focus of artificial intelligence now is to create systems that would be better tools for us. So there are some very practical focus areas how to make such systems much more usable. It's like improving the manageability of model behavior, improving efficiency in co-creation scenarios when people working with some generative tools, some personalization technologies, workspace technologies, reduction of communication transaction costs between human and machine, and also some challenges of informational error like fact-checking and so on. We are working on such tools, and that's a very, I think, natural transitions from the systems that are able to draw an image based on your text query to the systems that would be able to transform image to your needs. So it's text instruction-based image editing. It's our model Malvina that is able to transform images and so work in some co-creation scenario with human. Or Big Editor, it's also a tool to help you writing texts, because just use ChatGPT, it's not a very good idea when you are working on a big text trying to transform some parts of the text and so on. So we are now in the beginning of the era of interactive artificial intelligence. So through the times of deep learning revolution, we started with discriminative AI systems that was focused on solving tasks like image recognition, some classification and vision tasks. Then, after the invention of transformer models, we have created much bigger models. It was able not only to make some discriminative tasks, but also to generate and so on. And now we are approaching the interactive artificial AI systems. It was about solving a task that couldn't be solved in one step.
foundation of interactive AI systems is an agents. So what is agent? You know, it's also a very old term, and we already have different multi-agent systems in the era of good old-fashioned artificial intelligence. But now the creation of large language models make us able to create LLM agents, and this is a concept when you have your generative model and you have some things that make it, it's framing, it's just a term to different techniques how to change the model behavior from prompt engineering to fine-tuning. So we are in a transition from fundamental models to fundamental agents. Actually, it's pre-trained models that are able to make different actions, so it could be easily fine-tuned to your particular area. So the idea of chain of thoughts also, it's very old, and probably you have read the book by Daniel Kahneman, Think and Slow. You know his concept that the human has two modes of thinking. The first one is a fast, it's like when you solve some problem in just one step without some considerations, and the slow mode when we have some thinking process that will result in a solution. So it's interesting that reasoning in large language is, I think, very young, but you know that almost everything is very young in this area because you know the first model that was able to draw an image based on your query was published in 2021. So only 4 years ago, there was the first model that was able to do it. But now we are very angry when in generated image there is a wrong number of fingers on the hand. You know, and reasoning actually was invented 3 years ago. And at first there was idea just to say in a prompt, let's think step by step. So and it resulted in some step-to-step reasoning that resulted in better solving of different tasks. So, and now we are here. So we have some reasoning models, some models that are trained to make
much efficient reasoning, of course, like GPT-o1 or DeepSeek, of course. So let's a bit dive inside the systems. This is just basic things in framing how to change your model behavior when building some multi-agent systems. So you need some prompting, some functions, some retrieval augmented generations, some ways to fine-tune your model sometimes. And let's see how to solve the pure generative task with the agent system. You just take some large language model and say to it to act like a writer. At first step, it's like write some poem, I don't know. Okay, the result would be better or worse. You're able to make it better without some additional training. You just use the same large language model and say to it in a prompt, act like a critic, and feed to it the generated poem. It will result in some critical response about the generated text, and you then reuse such a response and the original poem and the same large language model and say to this model to act like an editor and make the original text better based on some critical review. So the result will be probably, in most cases, it would be better than the first generation. So it's a very simple pattern which is named reflection. And of course, reflection is a simple example of a much more general approach. And such a general approach is scaffolding. Scaffolding is about building some arbitrary algorithmic scaffold around your agent. For example, in a case of poem generation, you are able to generate not one poem, but maybe 10 poems, and there's some new role to range, to order poem candidates. And then after the editor, you could probably add also some controller that will compare the original task description and the result and say, is it okay or no? And if no, return to the first step, and so on and so on. So you are only limited with your creativity when creating such a complex scaffolds to solve different tasks. And of course, inside such a task, you're able to call some external tools to create some databases, to run some code interpreters, and so on and so on. So it's easy to integrate some existing informational tools in your scaffold to create some multi-system. One more important thing is word models inside large language models. Some people want to argue that large language models doesn't have any word models inside them. From my point of view, it's strange because if the model is able to write some consistent text about with some propositions and some consequences, it of course has some language model or some word model. But the word model in the case of humans is also not very precise. Some people think that Earth is flat or the moon is made of cheese and so on. But it's of course
world models, model is not the exact reflection of the original object, because model every time it's a simplifications, is some generalizations, and so on and so on. So of course, large language models has some world models inside them. That's simply because it was trained on the digital footprint of the society. So we have society that is acting in the real world and creating a reflection of a real world in our texts and videos and music and so on. So when training large language model on such data, we have a reflection of. So it's of course it's disturbed image, but it's a world model. Why it's such an important thing? That's because if you have some world model, you could use the same approach as AlphaGo or AlphaZero to solve real world tasks. Because you are able to create a policy network and evaluation network based on your large language model, and then proceed with some Monte Carlo research from the real world scenarios. So it opens a lot of possibilities for the practical applications of large language models. So human brain is also mostly consists of neurons, not of the brain cortex, but of cerebellum. So
Cerebellum is about world modeling. Also, there are a lot of other very important trends in artificial intelligence for now. For example, multimodal systems that are able to process different modalities, not only text. And of course, the Saint Grail of this area, new models. It's of course would be great to have some model that would be able to deal with text and audio and video and so on, like when communicating with people through internet messenger. It's you could send text or images or music or some videos, and in result get also the same mixture from other side. But there are some engineering problems that should be solved to achieve omni-modal models. Also, there are a lot of other very important trends, and I unfortunately have very limited time to say about each of them. But anyway, our area is quickly expanding due to high interest to it from the whole society. So that's why we have a lot for now and a lot of ideas and a lot of directions, begin from different architectures and finally ending with some biology of AI. It's like trying to use some biological methods to understand how models work. And also, AI technologies are rapidly evolving. And there are some in just 1 year, things could be changed completely. It's like from extensive scaling of training data sets and extensively increased computational budgets for pre-training, we are now to the era of test-time compute, and we have a lot of computations after the model training in multi-agent setups, for example. And also narrative that surrounds the AI could be completely changed, like, maybe 1 or 2 years ago, the dominating narratives around the AI was we are building AI for good, we are for ethics, for openness, open AI, open. And for now, we have completely different narrative, rivalry and regionalism and some expert limitations. And some people from the West says we should limit our experts to limit abilities of China to create advanced AI systems and so on. So things are changing very fast. Some things about how systems transformed for now. We are started, in the case of image generation, we started with a simply end-to-end model that is able to create an image from the text prompt. But future systems probably like multimodal language models based agent designers. So it would be probably agent systems that would be able to perform search, prototyping, evaluation, and communicating with people when working on such a creative project and so on. So it's how systems transforms through time. And also, very important dimension is a level of immersivity of the systems. That's about how we are working with such a system. So now we're trying to reduce some effort to interact with AI compared to current levels, to make models faster, to lower latency, to make it a bit clever to better understand our queries, our prompts, trying to make some multi-stage communications with the model and so on and so on. Finally, it will be resulted in some level 2 immersive AI systems when the effort required to interact with AI will be reduced to the level for the effort required to interact with humans. So it will be a big milestone because it will be time when you will communicate with AI systems without learning how to do it. Just you will reuse all your experience of communicating with humans to communicate with such systems. So it was some transparent way how to communicate with such systems. But finally, it will be probably resulted in level 3 immersive immersion, like the times when AI will be perceived as a part of yourself. So like, some current technologies provides the same level of immersion. It's like our clothes. It's perceived like a part of our bodies. You don't have explicitly in mind that you have clothes. It's like a part of your body. So our goal is to create such systems that will be perceived as a part of the human being. And some final considerations about the tale of intelligence explosion. Some guys said be now in a way to some catastrophic error when we will create the systems that will be able to improve themselves, and finally it will result in some intelligence explosion, and that will kill all of us, of course, and so on and so on. I think it was already considered by the XKCD how to predict the future. So probably we need a lot of cakes, but I think not, because almost every exponent in a trend is actually a sigmoid function, some logistic curve. So my time is probably over, so that's why I. Okay, I will finish in 1 minute. There are some limits that will change the trend. So in the future, probably we will not have intelligence explosion, but some curve that will lead to some physical limits of computation. There are different physical laws that will change those expandable sigmoid. Of course, we have some challenges for now. There are a lot of open questions in AI advancement for sigmoid. Of course, we have some challenges for now. There are a lot of open questions in AI advancement. Some problems on phoneme and bottleneck of how to create much more data-efficient systems because the tempo of growth of digitalized information is still slower than the tempo of computational budgets growth. Some random curves. We will provide this back to all of the conference people, so you will be able to analyze it deeply. So the final slides is about books, which I strongly recommend for you to read, to make better understanding of how things are going and where they're going. And thank you for your attention.
We still have some time for questions, but very brief questions, very brief answers. Otherwise, we will miss coffee. Okay.
you for some technical questions. When there is a transfer from LLM to MLLM, there are several channels, and you showed this slide with audio, video. So technically, how it's now implemented? I mean, audio not
use some newly invented recurrent architectures like Roku or something like that. Or maybe make some dynamic attention field over the long context and drive such an attention field, and so on and so on. So there are a lot of changes how to do with it, but the general approach
of history. More than 1,300 reports. More than 4,000 participants. Innovative trends. Meetings of ideas. And more. Pattern recognition and information processing. Embedding the future.
Yes, we shall start. So we need to start actually because we are quite out of schedule now. So now we will have a quite complicated session because most of our reports will be online. But still, so we have to do this. And I would like to kindly present you session chairman, who is Tir Seleznyov, is an associate professor at the Department of Mathematical and Computer Modeling, Far East Federal University. So, Mr. Chairman, you have a floor now.
Thank you so much, Alexei. Dear colleagues, it's a great honor for me to be the chairman of this section. I'm from far east of Russia, and I was lucky enough to get to Minsk. But unfortunately, not everyone in my section was able to attend in person. So today we have a lot of online presentations. So I'd like to introduce the first presentation, number 32, Usatyuk Vasily and Yegorov Sergei. Do you hear us? Vasily, are you here? He up hand. Maybe he writes something. Vasily, we can see your presentation and don't hear you. Oh, okay. But we don't hear you. Don't hear and can see. Okay, technical problems, it's normal in such conferences. Okay, let's wait for a minute. Our technical group tried to solve this problem.
Are you hear me?
Okay,
Yes, and we can see you.
nice to meet you.
Amazing, amazing. It's some problem with rights, as I understand, in Chrome. Okay, I will share my screen.
Okay, we'll
Just
wait.
Chrome.share sounds access and access to screen. Okay. Yeah, I hear you. Okay.
Okay, let's start.
Okay, you see my screen?
Yes,
Okay. You see my screen?
Yes.
clearly.
Okay. Yeah.
Okay, let's
My
start.
presentation will be related to the methods of the filter expansion. It's methods for high performance quantum sensing or small FPGA, AGI devices, which based on the graph sparse random projections. Okay, outline shall be considered related methods, basic algorithm for the feature expansion based on the graphs, theory, very sketch of the proof on the improving of distortion, experiment results, and conclusions. Okay, modern image processing and even language processing require a lot of high discriminant features extracted from images or sound or text. Main problems that Gaussian and dense extraction and sparse projections require a lot of resource and have a problem with the correlation between such features. But low-weight devices, or for example quantum sensing, require high efficient sparse representation for analog processing and high processing for such small devices. Okay, you see general methods from the very same classes like Johnson-Lindstrauss, graph-based methods, random Fourier features, sparse projections, well-known portraying convolutional neural networks, all layers before top layers, final classification layers. And at last, maximal size clip feature extractions, which require a lot of computation power and currently the most powerful feature extraction things. Okay, what we will use? We will use bipartite graphs. Bipartite graphs, it's a graph represented by graph of Tanners. It consists from two types of edge. You see, it's checks nodes and variable nodes. For such variable nodes, which will be used to feature extractions, we can define closed cycles. Closed cycles is closed path from the variable node to itself, which are represented by priority check matters. We will construct such priority check matters of you see sparse codes, LDP sequence. Okay. Of course, on the edge, you can always wage some ternary or quernary volume. Non-binary edges. It's a non-binary ternary LGBC and projects using such graphs. Okay, how PEG works? PEG is a just greedy algorithm which try to maximize some metrics. Here is not cycle properties. Here's a spectrum. A spectrum is improved connection properties of such cycles. Such metrics allow to estimate distortion power of features in such way. Okay, I'm very tight in the scheduler because I use it times. I will just say that you can prove a bound related to the distortion according to cycles. Such bonds relate on the dot martingales differences and some techniques related to the closed paths, what we call trapping sets structures. Okay, as a result, we can show that improving of such ACE or EMD Wally decrease distortion for such sparse ternary projections. We will consider small datasets, 10 classes and 100 classes, ImageNet, ImageWeb 100. And we will use dense random Gaussian projections with linear classifier and such graphs. As baselines, we will consider Erdős-Ringier graphs. Usually random graphs like Erdős-Ringier use like baseline in such cases. For discriminant of features for classification, we will use cosine distance. We will discriminate 32 features for 10 classes and 64 for 100 classes. Okay, clear that cosine distance presolving of features extracted for Erdős-Ringier is worse than PEG. You see that it closes such wall, it shows that we not destroy feature space. It's easy to understand why, because too dense representation. Even you divide and, for example, drop half of the matrix, you will still have a lot of gaps. Okay, after linear, it's not softmax, it's linear classification. Linear classification of such features. You can consider some kind of embedding linear classification, not training softmax. It's important. We get for 100 ImageNet 99%. What it shows? It shows that such graph, like PEG, can be used for fast feature extraction, and for small number of classes can be used as some kind of very fast implementation of convolutional layer without convolution at all. Okay. For ImageNet 100, not enough to use linear classifier. We use training one layers of softmax, and it show 88, 96%. Summary. We show that PEG with ACE and ternary projections allow to do fast filter extractions and allow to get 100 class classification of images with extremely fast speed. No, it's for example we implemented in sugar break. Sugar break is a FPGA which have only 8 DSP blocks, and its work is enough. Okay, questions?
Okay, thank you, Vasily. Do you have any questions? Okay, thank you for excellent report, and let's move on to the next report, and Vasily Zaduk, come back to us with the second presentation. Okay, Vasily.
Okay, second report.
Okay.
Okay, you see my screen?
Yes, we see.
Okay, second report will be related to the some kind second topics related to the graph neural networks. It will be not about feature extraction, but improving improving all the processing of such features using spectral embedding. Okay, main problem of graph neural network is over smoothing of features. Why? When we increase number of layers and graph neural networks, very fast features become worse discriminant on any metrics. No, we will use cosine metrics, but it will be resolve any metrics. We provide new metrics, such metrics is a matrix permanence, and connect matrix permanent with the spectral graph of graph embedding, and shows the increased spectral gap, improve feature discriminant on the deep layers of graph neural network. Let's begin. Permanence is determinant without sign components. This is why it's an hard problem. It's a certain fundamental problem of perfect matching, based on sampling models, quantum computation, and error corrections. Permanent defines how to allow features distinguished. But practice, of course, permanence can be estimated because it requires guesstimation. Okay. Neural network approximates tractable energy approximation. And this approximation we call better permanent approximation. Such approximation relates to the belief of partition algorithms on factor graphs and provides bound distributions of features under the map or elemental body. Such matrix is optimal on the expander graph. Okay, we have two metrics: permanent, which is close pressure, and better permanent. Better permanent approximates them for gradient distance, for Bettiesian spectrograph bedding and other practical methods. And we provide hypotheses that the difference between permanent and better permanent can be due to measurements for preventable smoking. Because permanent components improve optimal distinction between features. Better permanent provide for us training according to real spectral denominator. We will consider quasi-cycle graph, not random graphs as in previous presentation. And we will construct such quasi-cycle structured graph with approach that from previous presentation with improved quality of connection in such representation. Okay, and during the train, we will use such kind of metrics. Regularization of permanent and better permanent defined on such graph or its metrics representation. Here you see subgraphs. Because all metrics have large sizes, for example 1030 to 1030, we can consider only small submatrices because permanent become exponentially hard to estimate. We consider approximation of some maximal size of submatrices. And we will show that such approximation provide to us very good approximation for the spectral graph. Without better permanent approximation, spectral graph increase dramatically, more than 1,000 times for symmetrical metrics. For use spectral graph embedding, we will use random bond tracing models. It's a model which use connecting metrics of our graphs, weight on the edge according to features extracted from data, and SI, SJ, it's just spin elements. Spin elements used for encode such features which we extract from the or image, text, or sound. Exists Nishimura temp. Nishimura temp is a template of maximum likelihood decoding. On such temp, random bond EC model have phase transaction and provide for us clustering, optimal clustering of features for such spectral embedding. And make cluster separation. Cluster separation, if we have a label of the class, became a tool of the two classes classification. Let's consider experiment settings. We will use net Kusil DPC graphs. It's represented on the slides you see below. We have again Erdős-Rini random graphs and non-optimized net Kusil DPC. We will compare non-optimized met Kusil DPC with optimized by better permanence and consider on three classes: ImageNet 10, ImageNet 100, and binary classification cat dog from the gang. It's a classical compare of the spectral graph embedding around using in quantum physics. And we see that better permanent optimization provides for us for binary classes improving to 6% accuracy, 18% accuracy for image 110, and 23% accuracy improving compared to the graph without optimization. You see that usually Erdős-Rini even better than quasi-cycle DPC. Why? Because if you not make better permanent optimization, you don't distinguish a thing of features. If you not make penalty for the better permanent, you will not get it after, for example, even one layers of optimization. Metrics you see from the right parts. Okay, let's summary. better permanent and permanent complex metrics allow to us improve accuracy of image classification with decreasing number of processing elements for such. What it means? Previous presentation related to the feature extraction. This is to the use top layers, last layers which make classification. And we show that multi-layer perceptron can be changed by spectral graph embedding draw and decrease number of requirements parameters and improve speed of neural network and increase accuracy quality. Moreover, you see we have Bayesian multi-class prediction. We can even estimate uncertainties. Overlap of the Gaussians provide uncertainties on the prediction. Such methods provide to us a way to decrease number of false detection, for false classification, using Bayesian uncertainties of the Gaussians. Okay, I think it's all questions.
Okay, thank you once again, Vasily. Do you have any questions? Thank you, Vasily. We don't have any questions, and we go to our next presentation, number 73, John Nana. Do you hear us? John Nana. Hello. John Nana with topic localized bootstrap constraintive learning network for few shot pulsar image classification. Do you hear us? Can you turn on your microphone?
Okay.
Okay. Nice to meet you. So we see the presentation. You can start.
Okay. Okay. Nice to meet you too.
Okay. We see slideshow.
Hello everyone. I will present today's sharing content under title Localized Bootstrap Capacitive Learning Network for Few-Shot Pulsar Image Classification. It's following aspects. That is of time and render image permanently. Pulsar extends that by integrating the multi-channel, multi-parameter radar image system. Pulsar has significant applications fields of topographic mapping, environmental monitoring, natural disaster assessment, agricultural yield estimation, national security. The SAR system can summarize four states from scene to product map, application mapping, eco application, signal processing, image processing, and objective interpretation. Our research is focused in stage 4. Traditional image classification tests typical divided into categories: object level and pixel level. At the object level, each image corresponds to a level, while at the pixel level, each image corresponds to multiple levels. Although monocyte images are the object level classification tests, they are different from traditional classification. Each image corresponds to a level, but the image has multiple semantic information. For monocyte images, their library not only has professional domain knowledge, but also has an extremely high level investment, making it difficult to obtain their level samples. In monocyte image classification, methods can be divided full meter patterns, traditional analytical method, and deep learning method.
Something gone wrong. We can't hear you once again. Do you hear us? Hello, do you hear us? We don't hear you. Hello, do you hear us?
Now, yes.
Okay, we have some technical problems, but now we saw a very interesting presentation and a great example of how artificial intelligence can be used not only as science but in our everyday life. I think it's some kind of future. Okay, let's go to the next topic, and I introduce Huo Jianyan with topic number 117. Design and implementation of a lightweight UGS system using dial gearphones. Do you hear? Hello? Do you hear us? Can you turn on your microphone?
Sure.
Oh, thank you. Nice to meet you.
Nice to meet you too.
We wait for your presentation. Can you share screen? Okay, we see it. So, if you're ready, let's start. We see that your video. Oh, okay. We don't hear anything, but we see the screen, but don't hear you.
I'm playing the video. Can you hear the video?
Okay. Now we hear you. So if it problem with using video and microphone, I think you can use scroll box in the bottom to change slides and talk. I think it was a kind of solution.
To share
Manually.
of presentation, design, and implementation of network UGS system using the GFOD. I am Hu Jinyang. This paper was completed under the guidance of the supervisor, Professor Fan Hongqi. The research team of the paper is from the College of Electronic Science and Technology, National University of Defense Technology. This presentation is mainly divided into 4 parts, namely background, main research methods, result, and conclusion. Let's begin with background. Our project aims to address the issue of detecting and monitoring illegal human and vehicle targets in border areas and key regions. Traditional infrared optical sensor systems are restricted by the environment, resulting in monitoring blind spots in areas with limited field of view, which poses significant risks to detection and monitoring. So, it was proposed that an attended ground monitoring system based on seismic wave detection. This system features strong environment adaptability, passive detection with low power consumption, and a modular assembly that facilitates portability and operation, providing a new solution for the detection of human and vehicle targets in key regions. Our innovative feature mainly consists of 3 parts. First, regarding the detection algorithm, abnormal signals are detected using the short-term Avenger, long-term Avenger algorithm. For Avenger measurement, time difference of arrival, Avenger calculation based on cross-correlation for time delay estimation is adopted. Finally, the support vector machine model is used for target classification. First, let's introduce our detection algorithm. We use the long short-time window detection algorithm, whose principle is as follows. First, a long time window is used to select a time period for collecting the Avenger date response, and a threshold is determined based on this Avenger. Then, within the long time window, a short time window performs step-by-step scanning to extract abnormal signals. The specific process is shown in dynamic diagram. In this study, the duration of the long time window and the short window are set to 0.2 seconds and 0.02 seconds. Figure 1 and Figure 2 show the target detection performed on the collected date, where the red and the green dots mark the time points when target exists. Next, we will introduce the Angel measurement algorithm. The Angel measurement algorithm consists of 2 main steps: spectrum subtraction for noise reduction and the total algorithm. The spectrum subtraction method is used for denoising, and its principle is similar to collector cancellation in radar. The algorithm subtracts the noise power spectrum in the frequency domain, retains phase information to reconstruct the signal, and performs independent optimization for each channel. Before angel measurement, cross-correlation calculation is performed on the date to obtain the time delay of a set of target dates in the 2 sensors. Finally, using the time difference of arrival principle, calculations are performed based on the geometric relationship between angel time delay, seismic wave propagation speed, and the given spacing to obtain the target's angel information. In the calculation, Considering the actual geometric relationship, we conduct an approximate calculation of the formula. The figure is a target angle measurement result from one experiment. Next, we will introduce our classification algorithm. We use the support vector machine model for classification. Based on existing research, the figure vectors we adopt mainly include the zero crossing rate of the date and the frequency domain energy. The zero crossing rate is mainly used to analyze the frequency characteristics of the signals, while the frequency domain energy reflects the energy concentration of different targets, as can be seen from the figure. On the right, the date of pedestrian, the red dots, and the vehicle, the blue dots, can be well distinguished by the zero crossing rate and the frequency domain energy. So we use binary classification method based on zero cross rating or zero crossing rate and the frequency domain energy. In the system, our date detection process is as follows. First, when detection is performed, then, based on the detection results, a decision is made on whether to proceed with target classification and detection. This approach can, to a certain extent, save computing resource and multi-system availability. This is an output result of our detection program for pedestrian target, including the target type and the confidence level. For the handwear, a door LGT2 seismic vibration sensor array is used in conjunction with a high-performance data acquisition module. Enabling high-sensitivity signal acquisition and real-time processing. The data acquisition relies on a data acquisition card from Shenzhen Virginia Company, which features high-speed data processing capability. Finally, we have developed a graphical user interface. After clicking operation, users can select a parameter such as sampling rate and CY. Then, the system starts collecting seismic wave data sites will simultaneous, performing angle calculation and target classification. The classification results will be displayed after the target test box. The early warning level indicates whether a target is determined. If a target is detected, the level is displayed as high and all functions operate normally. Lastly, let's briefly review this research, aiming at copying points of traditional antecedent border systems, such as numerous monitoring principles and high power consumption in complex environments. We proposed a network UGS based on the seismic vibration sensors. Through technological development and verification, we ultimately achieved accurate detection, angle positioning, and classification of illegal human targets, providing a practical and implementable technical solution for low-power port security scenarios. In terms of technological innovations and achievements, we focused on completing three key risks. First, we improved and integrated short-term Avenger, long-term Avenger event detection, total angle calculation, and stream target classification algorithms, forming a progressive processing workflow of first scanning events and collecting angles. Finally, classifying targets. This workflow significantly reduced the demand for computing resources. Second, we overcame hardware adaptation limitation. The interprocess of target detection, recognition, and angle determination can be completed using only a portable laptop. Balancing the system's network that with flexibility in on-site deployment. Third, During the experiment, we accumulated and organized a seismic wave dataset covering different target types, providing data support for subsequent algorithm optimization and similar research. Regarding future work, we plan to deepen the research from two aspects. On one hand, we will continue to optimize the existing algorithm by strengthening the sample size and adjusting model parameters to further improve target recognition accuracy, while strengthening test verification in complex environments to enhance system stability. On the other hand, we will explore a three-sensor array solution, leveraging multi-sensor collaboration to improve target positioning accuracy, breaking through the limitation that current drone sensor setup can only achieve angel positioning and releasing process positioning of targets. My team and I would appreciate any constructive feedback.
Okay, thank you. Do you have any questions? Okay, we don't have questions, and thank you for another interesting and innovative solution in all aspects. Okay, and let's go to next presentation. It's number 44, Hasanov Ildar, from data to diagnosis. Voice as a digital biomarker in Parkinson's disease patients. Ildar, are you here?
Good time of day. I will present our research. My name is Diana. Good time of day.
Have a good day. Nice to meet you, Diana.
Nice to meet you, very too. I'm happy being here. Thank you. Can I share my screen?
Yes.
Okay. If you don't mind, I will just switch off my video to make the voice better, and then I will get switched on. Thank you. Can you see it well?
Yes, we see it clearly.
Thank you so much. Let me start. Good day, dear colleagues. My name is Diana Hasanova, and I will present you our work on voice and digital, on voice as a digital biomarker in Parkinson's disease. This project is part of the brain phone study carried out in Kazan, Russia, and focuses on how quantitative analysis of voice recordings can support diagnosis and monitoring of Parkinson's disease. The topic lies at the intersection of neurology, signal processing, and machine learning. Therefore, I will explain both medical background and computational methodology we have applied. So let me introduce from this slide. Parkinson's disease is the second most common neurodegenerative disorder worldwide, and according to World Health Organization, it is also one of the most disabling neurological conditions, and the diagnosis is based on two of three cardinal motor features, and the first one is bradykinesia. It's the medical term for slowness of movement, and it refers not simply to moving slowly, but to difficulty initiation of movement, reduced amplitude of movements, and loss of automatic gestures. So the second one, bradykinesia, is mandatory, and the second one, it can be rigidity. It describes like increased resistance to passive movement. For example, when a doctor tries to move a patient's arm, the muscle feels stiff, almost like bending in a lead pipe. And the rest tremor is the last one. It's like an involuntary shaking of the hands, arms, and maybe legs when the muscles are not being actively used, and typically looks like a rhythmic pill rolling movement in the fingers. However, all these three signs can appear together, and the problem is that the Parkinson's disease is usually recognized very late. Here you can see the workflow, the flow of the disease in its pathogenesis. So the disease starts with preclinical stage in the brain long before symptoms appear, and in the prodromal stage we can see non-motor symptoms. It's like sleep disturbances, loss of smell, or depression. And all these things are not specific for the disease. That's why we cannot make the diagnosis here. At the clinical stage, we begin to see motor symptoms. They become obvious, and often many years after disease onset. So by this time, almost 60–70% of dopamine-producing neurons are already lost. So furthermore, current evaluation is episodic and quite subjective. It relies on neurologist examination once or twice a year. Different doctors may interpret symptoms differently, and the subtle changes between visits are often missed. This is why there is a growing interest in the objective digital biomarkers that could allow more continuous, earlier, and unbiased assessment. Voice has attracted special attention because in Parkinson's disease it's almost 90% of patients develop a speech disorder, so-called hyperkinetic dysarthria. This condition affects every aspect of the speech. It's pitch, loudness, articulation, rhythm and fluency. So the voice and the speech affected deeply. And from the computational perspective, these features can be captured using acoustic analysis. And what is important, the voice is non-invasive, so we don't need needles, radiation, only a microphone. And voice can be collected quite frequently and remotely using smartphones, for example. And acoustic features are quite quantifiable, unlike subjective clinical impression. So voice analysis offers a promising path towards scalable and even data-driven neurology in medicine. Our study that we've done included more than 100 patients with clinically confirmed Parkinson's disease in the stages 3 and 4 of the Hanyan-Yar scale. This quite advanced stage. And moderate and advanced stage of the disease, and also 100 healthy controls that were age-matched with no neurological condition, and each diagnosis was confirmed by a movement disorder specialist according to International Movement Disorder Society criteria of Parkinson's disease. That is standard in the neurology. This ensured that the patient group truly represented Parkinson's disease. We also applied strict exclusion criteria. Only patients with speech disorders that unrelated to PD, for example, post-stroke, vocal cord surgery, some dystonia, and others, were excluded, all these patients. And this way we isolated voice changes specifically caused by Parkinson's disease. Every participant performed 2 standard tasks. The first one was sustained phonation of vowel A for at least 5 seconds. That allows us to analyze vocal stability in a controlled, simple manner. And reading a short, validated text message, which reflects natural connected speech. Continuous connected speech, yeah. Recordings were collected in real clinical conditions using smartphone with 44 kilohertz sampling rate and 16-bit resolution. And we've made that choice because if the biomarkers are to be scalable, they must work with everyday devices. So smartphone was one of the widely applied things that is used in the clinic, outside the specialized clinic also. We extract a large set of acoustic parameters with PRAT, grouping it into 3 conditions like sustained phonation, continuous speech, and a mixed one when we mix both of them. These samples include pitch-related features like mean pitch, minimum and maximum pitch, semitone range, and standard deviation. This reflects how variable or monotone the speech can be. We also measured perturbation measures like jitter, shimmer, and so on to see the variations indicating reduced motor control of vocal folds. Also, noise and harmonic ratios were seen. It's harmonic to noise ratio, HNR here, glottal to noise excitation, GNE, and harmonic dominance, H1, H2, to reflect breathness or maybe incomplete fold closure and excessive noise in the signal. There were also spectral features like capsular peak prominence, to see the clarity of voice and if it correlates with dysphonia at all, and dynamic and prosodic features like slope and tilt. We also computed integrated scores like acoustic voice quality index and acoustic breathness index. You can see them here, and this multidimensional approach allows us to capture the complex signature of Parkinsonian speech. Results, there was a lot of really different results, and they all in fact demonstrate significant degradation of glottal stability in Parkinson's disease patients, evidenced by reduced GNA values, glottal noise excitation, and this aligns with prior studies of PDE. And we notably see the elevated harmonic richness in Parkinson's disease, and this reflects our maybe cohort's early stage dominance, as the duration of the disease was about 7 years. But we went through the standard data science workflow, and at the end we make the reduction of dimensionality to tackle the multicollinearity problem we identified, and given the large number of features we faced it, as many pitch-related measures were very highly correlated, and various inflation factors exceeded 100 for some parameters. So we applied principal component analysis to reduce dimensionality while preserving variance, and the first principal component explained 58% of variance, and the strongest loadings came from glottal to noise excitation and harmonic richness. And when we compared groups, PD patients has significantly lower GNA values compared to controls that reflects glottal insufficiency, and PD patients has significantly higher H1, H2 values that reflects harmonic monotonicity and reduced prosody. So we also see that acoustic analysis can discriminate PD voices from healthy voices with quite high reliability. You can also see here a correlation analysis that reveals several notable associations between acoustic features and clinical variables in the data set, but it didn't exceed to 0.2. That is quite weak correlation. We also want to say that this analysis can make for adopters a non-invasive, objective and scalable biomarker, and using smartphone and acoustic feature extraction, we can see that glottal instability and harmonic monotonicity can reliably separate PD patients from controls, and it can be done earlier in the disease flow. That is very important for the treatment of the patients, and this represents a concrete step toward computational neurology, variety and medicine merge to improve patients' care, and we see it as a very important step to this to our future. Thank you so much. We'll be glad to answer questions.
Thank you so much. Yes, we have some questions. Very interesting speech.
Thank you.
Diana, thank you for your presentation. Very good results. I have 2 questions regarding your research. First of all, you told us that you used smartphones to collect the data, yes? And is it important for your classification algorithms some specificity of microphones? For example, every smartphone manufacturer use their own algorithms for voice preprocessing, noise reduction, and so on. Is it important or not?
Thank you for the question. really, we made all our audio recordings in the format of WAV, and as we make different tests, we see that there was no differences in the recordings in different smartphones, as there are several doctors all over Russia that are also in this project, and we tried different audio recordings, so we didn't see any changes and any differences, and it's a very good news for us.
Yes, thank you. And the
Thank
second question, could you please show the slide before results, one slide before results?
One slide, okay. I'm sorry, I cannot fix my camera, so sorry, just 1 minute. Before results, yeah. Research plan?
No, next one.
Here?
Yes.
Ah, okay.
As I understand correctly, most of parameters are overlapping each other.
Yeah, you're right, yes. It is, that's why a lot of different studies that was done before cannot, please let me explain this problem a little bit, because all major degenerations, it's a very complex thing because we cannot diagnose them earlier in the stage. So we can make a diagnosis. I tried to say it in the beginning of my presentation, that we can diagnose them only when we see the motor signs. And before we see the motor signs, it can happen, the voice can affect earlier in the disease course. That's why we tried to see the patients without any extrapyramidal signs from its neurological ones. Really, you can see that there can be some overlapping, and we even tried to group these patients to males and females to see if there are any differences. We see some differences, but they are not in noise parameters, yeah, like GNA and harmonic richness. So that's why we see that they were the most valuable for us.
And what are you planning to do with this situation? Maybe find some additional parameters, or try to mix these parameters in one integral or complex parameter to classify.
I see. Thank you. Yes, we are going to, maybe the decision will be in mixing different modalities. Not only speech, but also, for example, face recognition, or maybe some computer vision, like to see the bradykinesia in these patients. So we just now trying to find out if there are any explainable matter in the voice that we can explain it to the doctors, because the explainability in this thing is quite important to make doctors believe in IT technologies. Maybe you can see somewhere that doctors are quite skeptical about different things like that.
Yes, I see. Thank you very much once again for your presentation.
Thank you so much for questions. I was glad to be here.
Okay, thank you so much once again, and we go into our next topic. This is number 38, song Tsin, change point direction utilizing normalized entropy as a fundamental metric. I hear. We cannot see speaker. Son Tsin or Xia Shaolan. I think we don't have speaker. So next topic is mine. I think it's first offline topic for today. I can use both microphones, yes. Let's try to use this one. I think it's 1, 2, 3. Do you hear? So we're waiting for presentation. So I think I can start from prelude. So good afternoon, dear colleagues. My name is Tim Sebeznev, and I am from Far Eastern Federal University, associate professor of Department of Mathematical and Computing Modeling, Institute of Mathematical Computer Technologies. So today we are presenting our work on predicting red tides using machine learning. I have some co-authors. It's Kirill Kuzitsov, Elena Amosa, and Svetlana Afanasyev. All these authors go with me to MIS, and you can hear their topics also on this conference. Oh, sorry, not all. Kirill in Vladivostok now. And this work supported by Ministry of Science and Higher Education of the Russian Federation. So let's start. At first, I would also like to express my gratitude to the organizers, and in particular to Alexey Belotserkovsky for inviting us to participate in such wonderful conference. A few words about this topic, how we start to research. At FIFU, we have developed the platform of artificial intelligence called the FIFU AI, and we wanted to choose some small task to implement on this platform. So, since Vladivostok is a Pacific coast of Russia, all the problems we see, sea ecology and ancestral, is traditionally our flagship areas. So what is a red tide? This is a phenomenon where microscopic algae of phytoplankton multiply excessively, often disclosing the water to red, green, or brown colors. The danger lies in the fact that some species produce potent toxins. These toxins can kill fish, marine mammals, birds, and cause respiratory irritation in humans, and leads to surf poisoning through contaminated seafood. Even non-toxic blooms can be harmful for depleting oxygen in the water, creating dead zones. As you can see that images, the red tides are not always literally red. So the manifestation can vary greatly, but the consensus are very equally serious. Objectives. Our research had 3 key objectives. First, to find patterns in biological sample data to indicate the presence of red tide. Second, to compare effectiveness of 2 machine learning approaches. One, a supervised one using XGBoost algorithm, and unsupervised one using K-means clustering. And finally, to use these insights to contribute to the development of early warning systems. Data. The core of our work was a data set contains information from more than 1,000 biological samples collected on the Sea of Japan and the Bering Sea between 2009 and 2013 years. As a key indicator was used a proxy for red tide. Risk was algal biomass. This data we get from our colleagues from Far Eastern branch of Russian Academy of Science. First, let's talk about XGBoost model. To predict BMS, we used state-of-art XGBoost algorithm. Its task was to learn the complex relations between various parameters, like coordinates, date, algae spice, and quantity, and use them to forecast our target variable BMS. To ensure robustness, we employed tenfold cross-validation. Here you can see some formulas, but I don't want to specify formulas. I can take a few words about our key performance metrics which we used. We used R in square coefficient of determination, which measure how well the model explains the data, and MAP, mean absolute percentage error, which measures average prediction error. So let's talk about K-means clustering. What is it? In parallel, we applied an unsupervised learning method K-means clustering. Its goal is not to predict a specific value, but to discover hidden patterns and group similar data points together. So you can see in this image how it works iteration by iteration. So results of XBoost. As imagined, the result of XBoost model demonstration a high accuracy and sustainably for the task at hand. You can see that our coefficient of determination is 0.745 and MAP equals to 17.4%. So it's not so bad results. Results of K-means. The results from the clustering analysis were equally insightful. As the figures clearly demonstrate, the data naturally separated into clusters corresponding to different risk levels. Cluster 3, it's a cluster 3 clearly stands out when extreme values, signaling a high probability of red tide event. Cluster 1, on the other hand, represents a low-risk environment. Cluster 1, it's a blue one. And the clusters 0 and 2 represents transitional medium-risk zones. It's red and green. Conclusion. In conclusion, we can summarize our findings. The XBoost model, despite the relatively modest dataset size, showed excellent accuracy and can be used by biologists for direct prediction of agal biomass. Meanwhile, the K-means clustering results allow us to interpret the data by identifying zones with different risk potentials. This is extremely valuable for creating risk maps and early warning systems. So I think I be in time. So thank you for your attention. Do you have any questions? Any more questions? Okay, thank you. And I changed my microphone to chairman's microphone. Okay, hello, is it working? 1, 2, 3. Okay, and we come back to our session with another online presentation. It is presentation number 45, Xia Xiaolan, with topic multi-horizon node level resource optimization in cloud infrastructures via machine learning and particle swarm optimization. I hear Xia Xiaolan or Song Ting. Is anyone online? Okay, I think no. So we slide to the next topic. The next topic is from Anani Fruman, number 77, application of algorithm for selection and analysis of multicollinear input features in solving inverse problems of exploration geophysics. Oh, and it's here.
Thank you. Can you hear me?
Yes, we hear you and see the presentation very clear. Let's start.
My name is Sergei Dolenko from Lomonosov Moscow State University, and my talk will be devoted to some aspects of solving inverse problems in exploration geophysics. Inverse problems are a well-known type of problems. One of the areas where such problems arises very often is the area of indirect measurements. When we observe some results of real or numerical experiment, and by these results we need to determine some sought-for parameters of the studied object. This means that we need to make some estimation of the value or approximation of the inverse function of the values of parameters as function of the observed values. There are several approaches to solving such problems. One of very efficient approaches for estimation or approximation is use of machine learning methods. However, inverse problems have several not very good properties which hamper their solution. They may be opposed or even incorrect. They are often non-linear. They may have high dimension by output. They can be multi-parametric and or high dimension by input. And also the input features may be interdependent or even multicollinear, that is having linear relationship. The last two properties require reducing the data dimensionality, especially actual if we use such ML methods as neural networks. So in this study we consider methods of feature selection. So this is the goal of this study. Study and compare various methods for selecting informative features for this type of problems. Now to the physical statement of problem. Magnetic telluric sounding is reconstruction of electrical conductivity distribution in a geological section by the electromagnetic fields measured on the Earth's surface. In this statement we use here, the target parameters are just the depths of layer boundaries. So we can see the scheme of parameterization here. We said that the distribution consists of 4 layers, and the target values are the depths of the boundaries, 3 boundaries between the pairs of layers in a number of points along the profile of the section. Here the blue markers denote measurement points on the Earth's surface, and there are 31 points. And the red arrows denote the depths, the target variables, and we have 3 depths and 15 values along the section. If we try to study the structure of our data, we see that the whole data array, we have 6 components of the electromagnetic field. For each component, we make measurements on 13 various frequencies, and for each frequency, we make measurements in 31 pickets. That means that the total data dimension is 2400 plus quite a large number of input features. We can see that if we compute cross correlations between the features, they are not independent. In some places we see that there is quite a strong linear dependence, as Pearson correlation detects only linear dependence. On the contrary, if we look at the correlations with the target variables, it is not very high, so we may assume that the target function is nonlinear, and so the methods that can build nonlinear dependencies will be fit to solve this problem. Now, in this study, we use neural networks, the simplest version, multi-layer perceptrons, in two approaches, 3 single output perceptrons to determine each of the 3 variables, or a single 3 output perceptron. Each of them has 32 neurons in the single hidden layer. To reduce influence of initialization, we built 5 identical neural networks with various initial weights. We use early stopping with Adam optimizer. Now to the feature selection method. It is known that there are 3 main types of feature selection methods. Filter methods, and among these we use selection based on Pearson correlation. Embedded methods, we try selection based on the importance of features in gradient boosting models, and also selection by neural network weight analysis. The third type of methods, report type, are for high dimensional data are too computationally expensive, so here we don't use them. In a little more detail, the selection based on Pearson correlation, in this study we applied the following method. First, we find the feature with the greatest relevance to the target variable. Then we remove all the features whose similarity to the selected feature is greater than some preset threshold value. Note that in this study we estimate relevance and similarity by Pearson correlation, but in principle it is possible to use other estimations, including nonlinear. Now this procedure is repeated with all the remaining features until there are no features left, and so we get the final set of features. This selection based on the importance of gradient boosting models. We built gradient boosting model, then we solve the features based on their importance, and then we select a percent number of the most important features, say 750 features. So we get the other final set of features. As for selection by neural network weight analysis, a method is well known. Some details are the following. We train 5 neural networks on the initial set with various initializations of weights. Then we average the significance for each feature and sort them, and set the predefined number of the most significant features. This is one approach. The other approach that we detect the same number of most significant features for each neural network of the 5, and then we select features being detected in this way 3 or more times. And we finally have the fourth version of the set of features. Now let us see the results. Here we see the results for layers 1, 2, and 3. The deeper the layer, the worse are the results. Now here we can also consider the autonomous approach with a separate neural network for each output, and multitask learning when we determine simultaneous all 3 outputs. We can see that when we apply any type of feature selection, the error is significantly reduced, and if we compare the 4 types of selection with each other, we see that the best results are produced by weight analysis by artificial neural networks. Averaging works a little better, but they are similar. One more thing that I would like to draw attention to is the distribution of significant features along the frequency number and along the peak number. here we have results for two different types, components of electromagnetic fields. We see that the number of, this is for the neural network weight analysis by intersection. We see that the most oftenly used features are situated just in the vicinity of the pickets.
We'll lose connection, I think. I hear. Roman? Oh, Sergey, yes.
Yes. Some problems with my. Can you see my screen now?
Yes, yes, yes.
The conclusions. We see that solving the inverse problem with feature selection algorithms gives better results, much better than the twin set of features. Group determination of parameters, that is multitask learning, in some cases can be effective to reduce errors. And the most effective method of feature selection among the tested ones was based on the analysis on the NN weights. We also can see some conclusions regarding field components and also frequencies. In particular, lower frequencies make greater contribution due to skin effects, well known physical. That is all. Thank you for your attention.
Thank you. It's a very interesting presentation, and I have a little one question. Can you solve these inverse problems without neural networks?
Sure, we tried various methods in the area of machine learning. We tried neural networks, we tried linear and nonlinear regression, also with regularization, and also we tried gradient boosting methods. Among all, neural networks perform a little better. We explain it by the nonlinearity of the model dependence, and neural networks linear, nonlinear by their nature can solve this task a little bit.
Okay, thank you. Months ago, I was in China, in Changsha, Central South University, and it was a very great big discussion. Use neural networks or use old computational models and numerical algebra to solve some inverse problems. And we don't have one answer, use or not to use.
To our opinion, we should use both and compare the results. For various problems, the answer will be different.
Yes, thank you so much. Okay, any questions? No. So, thank you, Sergey. It was a very cool presentation. And we go to another presentation. Neural decision-making system for cargo distribution and transportation by groups of very-how robots. And speaker is Gong Shenshuo. Am I right? Gong Shenshuo? Yes. So, microphone and scene is yours.
Okay. Good afternoon, everyone. Thank you for being here. I'm Sheng Shuo from Bauman Moscow State Technical University. The title of our work is Neural Decision-Making System for Cargo Distribution and Transportation by Groups of Warehouse Robots. The rapid growth of e-commerce platforms immense demands on warehouse logistics, while systems from leaders like Amazon, and Jingdong Logistics are advanced. They share common shortcomings: low planning efficiency during peaks, high energy consumption, and dependency on manual labor. This highlights the critical need for smarter, more efficient warehouse automation solutions. To address these challenges, we propose a Mivar intelligent distribution and information processing system. It combines three specialized robots groups, like transporter robots, loader robots, and unloader robots. By using Mivar logical AI technology, our system achieves dynamic optimization of task allocation, aiming to reduce transportation time and energy consumption while enhancing overall system efficiency through multiple robot collaboration. This is Figure 1. Figure 1 shows our system's workflow. Cargo arrives at the loading dock, where loader robots operate. Transporter robots receive cargo from the loader robots, then transport it across the warehouse, and work with unload robots as the storage point to store the cargo. This feature is also the core of our system. It functions as a central brain based on real-time parameters like robot battery level and location. The system calculates a compatibility score between each robot and available tasks. Using Mivar rules, it then assigns cargo to the most appropriate robot and issues commands in the form of state variables, ensuring efficient and intelligent decision-making. The decision-making system is driven by a mathematical robot model. K equations like this match score for transporter robots at the equation 2. This question considers multiple factors: a binary check for sufficient battery, the Manhattan distance to the cargo, and the current energy level. Weights alpha and beta balance the importance of proximity and energy. The robot with the highest score wins the task. This is illustration. This is the illustration of our system. We tested the system in several scenarios. One loader robot was busy. One transport robot has low battery, and one unload robot was broken. The results were successful, as shown here. The system intelligently assigned tasks only to the available and capable robots. It correctly identified unavailable robots, providing user prompts, and completed all distribution tasks accurately, demonstrating high reliability. In conclusion, we have developed and tested our system that dynamically coordinates specialized robot groups, significantly optimizing warehouse workflow. It demonstrated high accuracy, stability, and reliability in experiments. For the future, we plan to track more complex tasks like multiple robots handling a single cargo item, the large cargo, or a single robot transporting multiple cargoes, and further test the system in real-world environments. Thank you for your listening. I am now happy to answer any questions you may have. If there is not, question, so go on. Thank you.
Okay, thank you. Hello. Okay, thank you for your speech. Do colleagues have any question? No question. So the next speech is 81 speech from Shen QG with MIVAR expert system based information decision model for automated robots in dynamic environments. You're welcome.
Good afternoon, ladies and gentlemen. It's my great pleasure to present our research titled MIVAR Expert System-Based Information Decision Model for Automated Robots in Dynamic Environments. This work is a collaboration between myself, Shen Sujie, and my colleague Gongshen Shuo, and Professor Varlamov Olegovich at Bauman Moscow State Technical University. In recent years, robots have become widely applied in industry, service, healthcare, and defense, and so on. Their role has gradually shifted from simple-pace planning toward more advanced, high-level autonomous decision-making. However, current methods face the two main challenges. The first one is machine learning, so powerful, but it's often treated as a black box. This reduces interpretability and limit controllability, which are critical for robots operating in complex environments. And the second one is many robotic systems are constrained by hardware limitation and cannot afford heavy computational loads. Our research aims to design such a system using the MIVAR expert system as a foundation. The model has several key features. The first one is multi-sensor data fusing, which enabling robots to perceive their environments comprehensively. The second one is real-time decision-making, crucial in dynamic and unpredictable environment, and transparent and controllable logic, which can make avoiding the black box dilemma. The fourth one is the integration of front-end and back-end information, which allowing interaction with external databases. The last one is low computational cost, which can making it feasible for resource-constrained platform. This is the system composition. To achieve this, we structured the robot sensing system into 5 modules. There is spatial environment perception and auditory perception, and proprioception, or named self-awareness of posture, and metal and texture sensing and hazard prediction. Those models allow the robots to collect both internal information, its own state and resources, and external information, such as environmental conditions and obstacles. Here is the mathematical modeling. To formalize the decision-making process, we introduced a 6-dimensional state space. This includes the shift state, robot state, and sensor state, temporal state, and interactive state with back-end system, and hazardous conditions. Transition between states are determined by control action generated by the expert system. And decision decision functions include speed, adjustment, and directional decisions, and human safety assignments. For example, the system can reduce speed when encountering obstacles, adjust trajectory based on safe directions, or activity safety protocols when interaction with variable groups. Here is the implementation in the Mivar expert system. The model was implemented in WIMI Razumodal platform, a tool designed for constructing and executing rules networks. The reasoning process follows 5 phases: perception, reasoning, decision, execution, and learning. We encoding 15 logical rules covering tasks such as restocking detection, obstacle detection, hazard avoidance, and human safety measures. The system then automatically generated a relational graphic linking object, parameters, and rules. The visual presentation not only supports debugging but also ensuring transparency of decision logic. Here is the experiments part and result. We test the model under 3 sensors. The first one is normal operation with typical self-depletion and moderate obstacle density. And the second one is hazard avoidance, such as high temperature, gas leakage, or coded human environments. The last one is communication failures, when the backend database connection is lost. RISA demonstrated that the system could automatically recognize their context, switch to appropriate rules, and maintain decision making continually even under communication failures by relying on local caching. The inference time remains efficiency between 5 and 20 milliseconds, highlighting the scalability of this rules-based approach. In conclusion, our study shows that the Mivar expert system provides a powerful and practical foundation for robotic detection making. Its main advantage include comprehensive 6-dimensional state modeling and transparent and interpretable logic, and linear computational complexity ensuring high efficiency, and strong visualization support for debugging and monitoring. Looking ahead, our future work will focus on automatic rules prioritization, optimization, and extending the model to support multi-robots cooperation, as well as exploring hybrid approaches that integrate deep learning with logical expert system. Thank you very much for your attention.
Thank you. Do you have any questions, my colleagues? Any more questions? Okay, thank you.
Thank you very much.
Interesting speech. Applause. Okay, and the last but not least one presentation will be online, number 91. Kantursky Jan and Klopotek Robert, fluid prediction based on artificial intelligence and edge computing.
Yes, so can you hear me?
Yes, we hear you with the presentation. Nice to meet you here. So let's start.
Okay, so hello, I'm Robert Kłopotek from Cardinal Stefan Wyszyński University in Warsaw. Today we present our proposed research on flood prediction using artificial intelligence and edge computing. This work explores our proposed system design and simulated implementation to evaluate how edge computing and AI can improve flood early warning system through local processing and real-time decision making. Probably maybe you heard that last year there was a great flooding in Central Europe which affected Austria, Czechia, and also Poland, from which we are. Traditional flooding monitoring system faces several critical challenges. They rely heavily on centralized cloud processing, which introduce high latency during critical events. Network dependency becomes a major issue during extreme weather, when communication failures are most likely to occur. This leads to delayed warnings precisely when the time is more critical. We address two fundamental research questions. First, how can deploying computation at the network edge reduce network latency and load in flood monitoring? And the second, what level of predictive accuracy can machine learning algorithms achieve for flood forecasting while running on resource-restricted edge devices? Our proposed innovation brings computational closer to the data source. Instead of streaming all sensor data to remote server, our proposed system processes data locally on each edge devices. This enables AI-powered prediction at the sensor level while reducing cloud dependency. The expected benefits of our proposed approach include reduced communication delays, lower bandwidth use, improved system resilience, and most importantly, real-time local alerts that don't depend on the network connectivity. Our proposed system uses a three-layer architecture. The sensing layer includes water leveling, rainfall, and IoT sensors, along with traditional sensors like soil moisture or flow rate sensor for extended prediction accuracy. The edge computing layer in our proposed implementation performs data filtering, machine learning interface, generates local alerts, and handles local processing, all happenings on-site without requiring cloud communication or intermediate action. The cloud inference layer provides data storage, visualization through dashboard, and broader notifications for emergency management. But critically, this layer is not required for intermediate flood warnings. Our proposed architecture ensures timed critical decisions happen at the edge of the network while maintaining centralized oversight and data persistence. The data flow process demonstrates the effectiveness of our approach. Sensors continuously collect raw data, which is immediately processed by each device. The edge device generates local alerts directly when the flood risks are detected without waiting for the cloud communication. Only summary data is sent to the cloud, not continuous raw storage streams as it is now in many such solutions. This creates an effective flow while critical alerts happen instantly at the local level, while comprehensive data visualization and management occurs at the cloud level. A key feature includes real-time local processing with intermediate alerts, efficient data transmission using summaries only, and autonomous operation even during connectivity loss to the main server. Our edge implementation uses proven hardware components, so Arduino Uno microcontrollers which connect to ultrasonic water level sensor, rainfall intensity sensor, communication modules, and also some LCD display for local feedback. The AI pipeline includes 5 critical steps. So data validation and filtering to handle some sensor noise, also some errors, feature extraction for temporal patterns, LSTM neural network for flood prediction, risk classification into normal, warning, danger level, and intermediate generation. All components are designed with constraints in mind, so optimized for microcontroller memory and CPU limitation while maintaining prediction accuracy. So the neural network are processed CPU only. Our performance evaluation saw significant advantages organized into 4 key different areas. So in latency comparison, showing the upper left, our proposed edge processing provides instantaneous alert generation, while cloud processing introduces delay of seconds to tens of seconds, which is critical time during fast developing events. The visualization in the upper right demonstrates the dramatic time saving achieved through the edge processing. This latency reduction can be difference between successful evacuation and disaster. Network efficiency showed in the lower left demonstrate about 90% reduction in data transmission through event-driven communication, making the system scalable to multiple sensors, and expected performance metrics shown in the lower right are based on the literature, which results in 95.5% correlation for 1 hour prediction, 70% correlation for 10-hour prediction. This is the 10-hour prediction for the evacuation time, and 6.3 seconds average response time in our simulated environment. This Edge AI provides 4 key benefits that work together in a synergy: reduce time latency, enable immediate response, lower network allows system scalability, high accuracy maintains reliability, and system resilience ensure operation during network failures. The practical applications include enhanced disaster preparedness system for communities, improved emergency responses, improved emergency service responses, also capabilities for authorities to act, scalable solutions that can be deployed across diverse geographical areas, and foundation for next generation intelligence disaster management infrastructure. Of course, there are many challenges and limitations that are included. The approach has clear advantages, so real-time processing, network efficiency, system resilience, and cost-effective scaling using cost-effective sensors and devices. However, we also acknowledge significant challenges, including limited computational resources on each device, model complexity constraints due to hardware limitations, distributed maintenance complexity when something went wrong, and also update managers across multiple remote devices. Additionally, real-world deployment is challenging, and securing funding for field trials remain as significant obstacles that we are actively working to overcome. Furthermore, legal and regulatory restrictions, along with formal approval requirements for the Ministry of Climate and Environment of Poland, create additional barriers of implementation. These challenges create important research opportunities in advanced model optimization techniques, federated learning approaches across distributed sensors, and integration strategies for additional sensor modalities. Our novel field prediction system makes several key contributions. We demonstrated the integration of edge computing with AI specifically for flood prediction, enable real local processing and alert generation, reduce dependency on cloud infrastructure, and improve system resilience against network failures. From a scientific perspective, we have demonstrated a feasibility of machine learning inference on resource-constrained devices, qualified the performance benefits of edge versus cloud processing architectures, and developed an architectural framework for distributed flood monitoring systems. For technical improvement, we've planned to explore advanced machine learning model, include LSTM with attention mechanism for better prediction for evacuation, develop multi-sensor data fusion techniques, and implement federated learning approaches across sensor networks. Border application include extending this methodology to other natural disaster prediction system, integration with regional management system infrastructure, and conducting large-scale field validation studies across diverse geographical and climate conditions. Especially this diverse geographical conditions are that mainly the flood starts in the mountains, but the effects is visible in lower terrains. Thank you for your attention. We are excited to discuss questions about our edge AI approach to flood prediction and its potential application in disaster management. You can contact us by our emails or LinkedIn. Thank you.
Thank you, Jan and Robert. Dear colleagues, do you have any questions? No one questions. So, thank you once again. As it should be for the final report. Fundamental. So, thank to all participants. All the reports were very interesting. All the topics were different and covered various scientific fields today. And the geography of reports is truly amazing. So thank you everyone who took a part in this section. We did a great work. So now we're waiting for everyone to have a lunch in future. Thank you so much. Alexei, thank you.
Thank you, Tim.
I give you a
yes, really brave, and productive management of the session. And thank you, all of you. So please do not forget to come back to 20 past 2 p.m. Thank you to the lightning talk session.
Thank you.
Machine and deep learning, computer vision and signal processing, artificial intelligence and neural networks, cloud computing technologies, and more. Pattern recognition and information processing, embedding the future. Every word carries weight. Every idea is priceless. Lightning talks. Pattern recognition and information processing. Embedding the future.
Ladies and gentlemen, good afternoon, young talented researchers. So we are starting Lightning Talk session number 2, and I would like to repeat again rules. The first of all, so report as well as paper should be done by a young researcher, and it should be fit within 5 minutes only. So here you have a timer. So once 5 minutes will be finished, it means that you need to be stopped. But now I would like to give a floor to the first talk, which actually, so please, Galina, you have a floor, and 5 minutes as well.
Все работает. Hello everyone, my name is Galina and I'm here today representing BSUIR and Department of Electronic Computing Facilities. This work was done in collaboration with my co-author and advisor Dr. Ilya Azarov. Our presentation focuses on new approach to GAN optimization. We all know that GANs are a powerful tool for generating images, but they face persistent challenges. These issues are especially pronounced in multi-level or hierarchical architectures, which are designed for progressive narration. Errors can accumulate at each level, leading to distributional shift, collapse of diversity, and synthetic data degradation. This is a major problem, especially in fields like medical imaging, where high distributional precision is crucial. Our research aims to tackle these challenges by analyzing the root causes and proposing architectural and training solutions. In multi-level GANs, the generation process is progressive, with each layer building upon the previous ones. The hierarchical dependency can lead to accumulation of errors. This is what we need to solve. A distributional shift, statistical properties of the generational data drift away from those of the real one, forgetting key aspects of original data, as it shows in picture first level, in the level corner of slide. One common architectural solution is introducing the UNIT generator, which can improve fidelity, but it also leads to a problem called overconditioning, limiting its ability to generalize and capture the full diversity of the data distribution. So, to address both mode collapse and generalization simultaneously, we introduce imitation learning into our training process. We treat generator as a policy that aims to mimic the expert policy, which is derived from the real data distribution. The objective is to minimize the divergency between the generator's policy and the expert behavior in the feature space. But that's not all. We also introduced the annealed importance sampling to estimate the log likelihood of the generator's distribution at each training loop. This has proven to be a reliable metric for tracking distribution alignment over time. So in this slide, you can see the difference between a standard approach with a fractured distance and our annealed importance sampling introduction. In this slide, you can see the result of the implementing generational GAA method that achieves significantly higher annealed importance sample log likelihood estimates compared to a standard GEM and other enhanced architectures like those using UNet or multi-scale models. A higher estimated likelihood indicates a better fit to the target distribution. This demonstrates that as our approach produces outputs that are more consistent with real data. The additional learning signal and using annealed importance sampling from imitation learning helps to stabilize train, preventing divergence shifts and regularizes the generator's behavior towards expect-like outputs. In conclusion, our approach offers a promising direction for future research in generative models, particularly for applications where high distributional precision and data diversity are critical. Our empirical and theoretical study consistently show that GAI outperforms standard GANs in terms of training stability and distributional fidelity. That's all. Thank you.
Thank you very much. So, let's applause. Any questions? Just 7 seconds for question. Okay, thank you.
Thank you.
So the next speaker actually will be online. Please, Georgios, it's not number 2, but number 10. So online, please. Are you ready?
Just sharing with my ekran. May I start?
Not yet, because we have no screen at the moment.
Yep, we can.
So you may share. Yeah, could you switch to the demonstration mode, because we have the list of slides.
Yeah.
Thank you. So it's okay.
Can.
You may start.
Good afternoon. My name is Daniel Yushimbayev, and under our supervisor, Denis Sergeyevich, we created the distributed analytical energy monitoring system. That was our main goal to create it, and the main key tasks was the creating the system architecture, implementation of real-time data collection and visualization of this data. Thirdly, we should develop anomaly detection algorithm, and the last one was building a model to estimate the remaining life of the equipment. So where we can just use our platform or our algorithms. That was originally born to use it on the hydrogen fuel cell, where we can just monitor and analyze our data from our fuel cell, and that's why we can just predict the time of VR equipment. I mean, like, we can just predict the loss of some hydrogen, or loss of anode or cathode and something else. And that's we got there some problems with our delays, or we shouldn't choose the protocol of our platform. So the results of it on your slide, and the best one was an UIIP. There are some graphs of it. Also, we got the HTTP. We used the HTTP protocol, UDP, and WebSocket. If we are gonna tell about all of them. They just have some problems like timing, and that's why UDP was the best one of them. The architecture of our platform on your slide. Here you can see some devices that you can put to your server, and after client can see it on his slide, maybe by Apache Superset. Also, all data is saving on the SQL database. Here you can see the results of our work. Is some data that was rebrouted on the dashboard. So you can create the dashboard that you can just take some values of your voltage, of your current, or something else, and just visualize this information. After visualization, you can just recreate some algorithm by the time, and that's how we can just predict our NML. So, for example, the source becomes too large. For example, on the middle of our graph, and system detects the anomaly. So by the formula on your slide. Our predictive maintenance model was created by this formula. You can see that Y is our predicted, and A is our, Y is the estimate of remaining resource, the equipment, and A is number of anomalies. So all in all, we can say that, in conclusion, we can say that our key achievements, it's a high precision monitoring of network parameters and real-time visualization of them on Apache Superset. Of course, there was some predictive detection anomaly automatically and predictive function maintenance. Also, scalability and applicability. I mean that you can use our platform not only for our main idea, not for hydrogen fuel cell. You can use it everywhere. Where you can take some sensors and data from them. That was all. Thank you for your attention.
Thank you. A little bit out of schedule, but okay. Thank you very much. So now we're coming to the report of number 2, Baranova Vasilina.
Okay. Hello, my name is Vasilina. I am a postgraduate student at Belarusian State University, and today I present a novel video processing algorithm for detecting and performing initial orbit determination of unknown space objects using small aperture optical systems. This work addresses the critical need for accessible space surveillance technologies. The growing number of space objects, including debris and new satellites, requires cost-effective detection methods. While radar systems are precise, they are expensive. Optical approach offers comparable accuracy at a fraction of the cost, enabling smaller observatories to contribute to global monitoring networks. Our system features a mobile telescope with an aperture under 50 centimeters with video processing software. This approach enables smaller institutions to participate meaningfully in space surveillance efforts. The co-innovation lies in analyzing different frames from video sequences where the Fourier spectrum shape correlates directly with a space object orbital velocity projection on the frame plane. The detection process employs a sophisticated pattern matching approach. According to the algorithm, the input video stream sequence with n frames is divided into subsequences. For each subsequence, a difference frame is generated as a sine alternating series of sums. The difference frames of the subsequence are divided into blocks. For each individual block of the difference frame, the amplitude spectrum is calculated. Each block is compared against a library of match filters corresponding to no satellite with different orbital velocity. When multiple filters respond to the same region, our minimum distance creation selects the optimal solution, significantly reduced fall detections while maintaining high sensitivity. Once an object is detected, we estimate its orbital velocity projection and combine this with angular measurements to determine the slant range vector, then solve Lambert's problem via the Gauss method to determine the complete set of orbital elements from two position observations separated in time. Validation on the rocket stage, detected rocket stage, showed position errors around 2 and 8 kilometers and angular orbital parameter errors under 0.3 degree for angles and around 20 kilometers for semi-major axis. These results matching high-end systems. This method democratizes space surveillance with applications in debris tracking and collision avoidance. Future work includes automation and multi-station integration. Thank you for your attention.
Thank you. So we have time for questions. If you have, we proceed. Okay, no questions. Thank you very much. So the next speaker is Lopatko Eugenie. Report number 3, sorry.
1, 2, 3. Good afternoon, everyone. My name is Lopatko Evgeny. I represent the Laboratory of Robotics System, United Institute of Informatics Problems, National Academy of Science of Belarus. Today, I'd like to share our work on developing a mobile robot for high 2% indoor mapping using the robot operation system Rosnoyetik. Indoor mapping is specific challenges in robotics. Automation, navigation in indoor environments such as warehouse, hospital and research labs require not only present but adaptively. To address this, we rely on SLAM simulation, localization and mapping. SLAM always a robot to build a map of environment while simultaneously estimating its own position even without knowledge of the space. Its innovation and modern automation systems. We develop a mobile robot with a different drive system and integrate it into Rosnoyetik. The platform is compact, energy effect and health movie. A custom control driver was built to enable seamless communication between hardware and software components. The driver perceives motion control and real-time integration with sensor, including the Hocker UST10 LX lidar and well encoders for odometry. The system archive position actually 5 centimeters built to enable simplest communication between 10-meter trajectory with a strong result for indoor application. The future improved control, we introduced a logic subsystem that eject speed gains Kp, Ki, and Kd based on contextual parameters like speed and Taurian angle. Additionally, we applied genetic algorithm to optimize speed parameters during system integration. This dual strategy communication self-Taurian with environment optimization trajectory, dwelling 90% completed classical speed Taurian. Result. During testing, the robot successfully performed detailed indoor mapping. The integration of lidar and odometry combined with advanced filters. Result in had to map efficiently and stable SLAM performance. Compared to SLAM, our system improved mapping actually by 25%. It adapts. Looking ahead, we plan to integrate additional sensors such as IMO and RGB cameras to enable cinematic 3D mapping using Octomap. That will allow the robot to recognize objects, negative environment, and handle non-static objects. In summary, we developed a mobile robotics system that combination percent control, intelligence optimization, and robot sensor fusion. Fusion to achieve high percent indoor mapping. The system is built entirely on Rosmagnetic and demonstrate strong performance on dynamic environments. Thank you for your attention.
Thank you. Little bit out of time, but okay. Thank you. No time for questions. You're free. Thank you.
Thank you.
The next speaker, Himbiskaya Yelena. Please. Report number 4.
Good morning or good afternoon. I will present the work on segmentation-based attention masks for enhancing fundus image diagnosing. This study was conducted at Information and Computer Technology Laboratory of Belarusian State University. And our aim was to improve the classification of retinal diseases by focusing deep learning models on the most relevant anatomical regions of fundus images. Clinical background. Fundus photography reveals important features that are later used for diagnosis. For example, on slide we can see different diseases, and we can see that in fundus images with myopia, we see thinning and tilted discs, optic discs. Hypertension causes narrowing of blood vessels and hemorrhages. Diabetic retinopathy shows microaneurysms and exudates. Glaucoma is detected by an enlarged cup to disc ratio. Cataract leads to blurred low contrast images, and age-related macular degeneration produces drusen and pigment changes. So the accurate detection of those signs can be challenging, especially when in early diseases, and it awaits the method that will highlight those features. To guide the classifier, we first segmented key structures such as optic disc, optic cup, and blood vessels. We used a modified UNET, and we achieved dice scores of 95% and 88% for optic disc and optic cup. For blood vessels, we used UNET with a backbone of ResNet 18, pre-trained on public data sets. Also, we used overlapping of tiles with blending to reduce artifacts. Those augmentation results allowed us to build an accurate masks of discs, optic cup, and vessels. As a baseline for classifier model, we used EfficientNet B6, trained on a public dataset with 5,000 images. The model achieved 78% accuracy overall, but it performed well on myopia and AMD, but it performed poorly for diabetic retinopathy and for healthy eyes. This confirmed the limitations of relying only on global image features. So to improve the results of a baseline model, we used our UNET masks as attention masks. Each structure was weighted by multiplying images with these masks. We suppressed irrelevant areas and emphasized regions for diagnostic value. The same EfficientNet accuracy improved to 92%, and diabetic retinopathy and healthy eyes classes rose above 84%. In conclusion, segmentation-based attention masks significantly improve retinal disease classification. Accuracy increased from 78% to 92%, with major gains in the hardest classes. The model became both more sensitive and more interpretable. With this approach, supports reliable and transparent computer-aided diagnosis and has strong potential for clinic use. Thank you for your attention.
Great, Ted. Thank you. So we have time for questions. One or two. Okay, no questions, so please, you're free, applause. And the next lightning talk should be made by Karkotsky Alexander, number 5.
Good afternoon, dear participants. My name is Karkotsky Alexander, and the topic of my report is comparison of alternative methods to Laplacian pyramidal decomposition in image fusion problem. Image fusion is a process of combining multiple images of the same scene, captured with different exposure levels, focal settings, or sensors, into a single composite image that provides more comprehensive information. One of the classic approaches to image fusion is the exposure fusion method, which utilized pyramidal image decomposition. This technique employs Laplacian pyramidal decomposition, where the image is represented as a hierarchy of multi-scale frequency components. In this way, the aim of the study is to conduct a comparative analysis of the effectiveness of alternative approach to pyramidal decomposition in the image fusion problem. The study considers the following methods: classical Laplacian pyramidal decomposition. This method effectively preserves both the low frequency image components and high frequency details. We will let transform with different wavelets
The Euler transform enables simultaneous processing of image in both spatial and frequency domains. Our implementation employed Dolbesch's Euler's orders 1, 4, and 6, the fourth order symmetric Euler, and the first order coefficient Euler. Discrete cosine transform. The discrete cosine transform converts an image from the spatial domain to the frequency domain. The following metrics were employed for objective evaluation. SSIM quantifies structural similarity between images by comparing luminance, contrast, and structural patterns. Value range from 0 to 1, with 1 indicating perfect structural correspondence. Execution time measured in seconds using precision timing. This metric serves as an indicator of the method's computational efficiency. And PSNR metric measures the ratio between maximum signal power and noise power. Higher values indicate superior detail preservation in the fused image. For experimental evaluation, we utilized 68 distinct image sets from Google's HDR Plus burst photography dataset. This dataset comprises burst sequences captured with a single camera, along with corresponding reference images generated through HDR processing. This reference image served as a ground truth for SSIM and PSNR metric calculations. In this context, while the PSNR and SSIM metrics do not fully reflect the perceptual quality of resulting images, they remain available for comparative analysis between different fusion methods. On the slide, you can see an example of a series of one image. The highest SSIM score was achieved by the Laplacian pyramidal decomposition method, while the lowest performance was observed with the first-order Dolbesch's Euler transform. The highest PSNR value was achieved using the sixth-order Dolbesch's Euler transform, whereas the Laplacian pyramidal decomposition method yielded the lowest PSNR measurement. The fastest execution time was achieved by the first-order Dolbesch's Euler transform, while the Laplacian pyramidal decomposition method shows the slowest performance. On the slide, you can see images obtained by each of the method. Also on the slide is a reference image obtained by the HDR method. The experimental result demonstrated that the Laplacian pyramidal decomposition achieved the highest structural similarity with the reference image. The sixth-order Dolbesch's Euler transform yielded the optimal image restoration quality, while the first-order Dolbesch's Euler transform exhibited the most computationally efficient performance. Also, the classical Laplacian pyramidal decomposition method demonstrated a superior SSIM. It underperformed in other critical metrics, particularly PSNR and computational efficiency. In contrast, the Euler transform approach achieved more balanced performance across all evaluation criteria. This was especially evident when employing fourth and sixth-order Dolbesch's Eulers as well as the fourth-order symmetric Euler. Based on the comprehensive evaluation, the sixth-order Dolbesch's Euler transform emerges as the optimal approach, delivering the highest overall image quality. However, when computational efficiency takes priority, either the fourth-order Dolbesch's Euler or fourth-order symmetric Euler offers a favorable compromise, maintaining comparable image quality while significantly reducing processing time. That is all. Thank you for your attention.
Thank you very much. So a couple of seconds for question. No, I see none. Thank you. Applauses. So the next speaker will be online. Nastasia, are you here?
Yeah, I'm here.
Okay. Please share the screen.
Okay. Give me a second.
Number 6.
Okay. Can you see my screen? Can you see my presentation?
It's not that screen actually. So could you share your demonstration?
Okay, I'm trying. And now?
Yes. Great.
Thank you. My name is Gretchen Stasia. I'm a student at the Belarusian State University, and I would like to present my work written with my supervisor, Edward Alexander, reconstruction of the spectral image from RGB images. This study is about the problem of restoring spectral information from standard RGB images Why is this important? The color of plants is not just a visual characteristics. It actually reflects changes in the composition of pigments and can serve as a reliable indicator of plants' health. Therefore, this opens up new opportunities for more affordable and widespread environment monitoring. I compared two K methods, the convolution of color and reconstruction of the spectral image from RGB data. The analysis highlights their strengths, limits, and potential application in practice. Let's start with the convolution of color. This method is based on the idea that the color we see in an RGB image is actually the result of mixing many different wavelengths. The convolution allows you to unmix these signals. The difficulty here lies in the fact that the problem is often incorrect. There are infinitely many spectra that could produce the same RGB value. So, regularization and prior knowledge are necessary. If we're talking about reconstruction of the hyperspectral image from RGB, this method involves using hyperspectral images to extract spectral data. This method involves using some methods like machine learning, or maybe using hyperspectral data sets. One of the approaches to obtain hyperspectral images is to recover data from standard images. However, this process is accompanied by a significant loss of information at the spectral integration stage, which makes the recovery task incorrect and its solution ambiguous. In this study, I propose to use the residual neural network, USherNet. USherNet is organized as a system of parallel computing streams with a concat exchange of information between layers. Unlike traditional SQL architectures, here each layer transmits its output data not only to the next, but also to all subsequent layers, which ensures efficient feature extraction at various scales and contributes to a more accurate restoration of spectral characteristics. You can also see the architecture of that. The comparison of these two methods was carried out on the basis of a standard RGB image of the grass cover to obtain a reference spectrum. Each image was analyzed using a spectrometer. The second row of photos was obtained using the convolution, and the third using a neural network. It can be seen that the result of the convolution are less consistent and strongly depends on lighting conditions. A comparative analysis of spectral data obtained using a hyperspectral camera and reconstructed from RGB image images. Confinement that the narrow networks approach provides a more stable and adaptive solution. The use of spectral images to restore spectral information is the most promising method in plant health monitoring tasks, providing the necessary accuracy at the lower cost and high flexibility in raw conditions. Thank you for your attention.
Thank you very much. So, out of time, but okay, we need to proceed. Thank you. Well, the next speaker, we will skip the next speaker because so some other reasons he is not attending the conference. It means that we're turning to Soloducha Artyom report, talk number 8. So you have a floor, please.
Okay, thank you. Good afternoon, ladies and gentlemen. My name is Artyom Soloducha, and my topic of speech is controlled image generation with generative adversarial networks. So let's start with a brief introduction of why it is an important topic for us. So the main reason is that it provides control over generated images by neural network, as well as improves safety and ethics, and provides bias mitigation. It also facilitates evaluation and benchmarking of top models in terms of a more concrete analysis of the results, as well as reduces computational resource waste. So at the same time, solving this task is quite challenging for quite a few reasons. So the first one being is that most of data sets, lack of multiple labels neural network can be trained on. This leads to lack of control over specific features on images. For that, we will use the feature extractor to extract features from the images. Also, most of models rely on random noise as an input, so it leads to lack of control through latent vectors manipulation. For that, we will use a separate mapping network to map feature vectors to random noise. Even when trained for conditional generation, some model still relies only on its knowledge, which may lead to some problems when generating because it may ignore some part of the data set. For that, we will use a separate feature extractor to gain the knowledge of the images on. And also, one of the main problems is that current SOTA metrics for generated images quality estimation make too much incorrect assumptions and efficiently ineffective. So there is lack of confidence in comparison of multiple models. For that, we will use a recently introduced metric called CMMD. More on that later. So as a generative model used for comparison, we will use the generative adversarial network architecture because it provides good quality of samples and a fast inference time. The data sets we will use are the histopathology data sets because they have specific texture patterns, and they are also not present in ImageNet dataset the inception network was trained on, and also we'll use the NIS dataset for some other experiments. So what GANs we have used? We have used the Wasserstein GAN since it provides good quality of the images, and at the same time it has more like stable training cycle, unlike other GANs. When used with gradient penalty and spectral normalization with gradient penalty, we achieved convergence, as can be seen on the graphics there. We also experimented with a novel approach to GAN called R3 GAN. It employs relativistic pairing loss function and two regularization terms on real and generated data. And as it can be seen, the training process was also quite stable. So in order to estimate what was the best model in terms of quality, we employed different metrics for generative modeling, but we will focus our attention on the two most popular ones, those one being the Fauché inception distance and recently introduced CMMD metrics, formula for which you can see down there. So why the CMMD metric is important? Since it was trained, since it uses clip embeddings, unlike inception embeddings, which was trained on 400 million images with description, unlike inception with only 1 million images, and it provides more meaningful feature representation. So as it can be seen, we'll focus our attention on Freshen's distance and CMMD matrix. It can be seen that the lower the matrix, the better the image quality is. And in our case, we figured out that Freshen's distance don't usually show it so well as it can. And in our case, the Westerstein gun with gradient penalty showed the best results, and it can be seen that Freshen's distance failed to show it, while the CMMD did. So for controlled image generation, we use a separate network which translates the feature we received from the images to random latents from which the GAN can generate images. We experimented with Mani's dataset. We achieved some success because we can see that some of the features were indeed changed in the manner we expected, while on histopathology dataset we didn't succeed. And it is field for further research, since the histopathology images were not presented in ImageNet, so the inception cannot build a proper picture of feature representation for these images, and we cannot manipulate with them. So yeah, that's it. Thank you for your attention.
Thank you. So no time for questions. Let's applause. Okay. Feel free. Now we come into the next speaker, Adamova Alisa, talk number 9. So, please.
Good afternoon, dear colleagues. Today I will present our research on automated electrocardiogram analysis for early detection of cardiovascular diseases. As you know, cardiovascular diseases are one of the leading causes of death worldwide. This created an urgent need to develop automated, accurate, and fast algorithms for analyzing of electrocardiograms. In our report, we will explore one of the approach to solving this problem based on calculating the statistical parameters of signal using two different methods. We took heart rate variability, HRV, as a basis, the variability of the duration of cardio intervals, which allows us to assess the autonomic regulation and the state of the human body as a whole. It is one of the most popular functional diagnostics methods worldwide, which has found its application in clinical, experimental, sports medicine, as well as other areas. To conduct the analysis, it is necessary to select a suitable method for calculating the HRV parameters, as well as software for processing the original signal, calculating statistical parameters, and visualizing the results. The final stage will be a comparison of the result for different groups of signal, control and arrhythmic. There are several main approaches to analyzing RV. Our choice fell on statistical methods based on time series. In this study, two methods for calculating target parameters were used, SDNN and RMSSD, based on cardio intervals, which is a standard and based on the absolute increments as proposed by N.D. Viktor Fyodorovich Fedorov of Medical University Moscow. MATLAB was used for the initial signal processing and calculation of HRV parameters. Further processing of the obtained data was carried out in Google Colab. In the graphs provided, the signal of the control group are marked in green, arrhythmics 1 in red. The graphs on the left side of the slide demonstrate the RMSSD SDN ratio for the full and select sets. It is obvious that the area of intersectional signal types in the full sets is quite high, which necessitated the selection. The graph on the right side illustrates the result of both methods of calculating the statistical parameter of HRV. The increments-based method demonstrates a more obvious separation of signal types. The table shows the median values of statistical parameters for both methods. For convenience, they are displayed on a histogram. Obviously, for the methods with increments, the difference for different types of signal, control and arithmetic, becomes more obvious. This confirms the significance of difference between the two methods. The Fisher criteria was used. The results are given in the table. The obtained values allow us to assert the significance of the hypothesis of the advantages of the alternative methods over the standard one, which make it more promising for further research. Thank you for your attention.
Great time, so we have time for questions. I see none, so thank you. Applause, please. So, next speaker will be online, I hope. Budanov Konstantin, number 11. So please say something, you're alive.
Yes.
Yes.
Here.
Okay. Please share your screen. Could you share demonstration mode, not the not list of slides?
It's no demonstration.
Excuse me, could you speak louder and demonstrate, share the demonstration, not the list of slides? Or in case you're unable to do this, just click on each slide to proceed. It's also okay. It is the same. Well, you may proceed like this, but in this case, you need to click on each slide to go further. You may start. Yes.
Good day, my name is Konstantin Budanov. I represent Department of Information and Computing Systems, Penn State University, Russia. Let me introduce to you a report on the topic evaluation of effectiveness of the method of the multi-level amplitude discrimination of electrocardiographical signal in arrhythmia detection. The EKG signal is one of the main indicators of the stable cardiovascular system. The function of the head is a rhythmic process, so any deviation from the norm should be interpreted as a disease or anomaly. There are many statistical analysis methods for processing electrocardiographical signals that are used in the classification of conditions or diseases. One of the methods of the statistical study of electrocardiographical signals is the method of the multi-level amplitude discrimination, which allows to obtain the distribution of the amplitudes of the signals. The main objectives of the study are construction of actual distributions of the EKG signal, value patterns with arrhythmia and normal heart rhythm, the formation of the average distributions for each type of signal, evaluation of the statistical significance or difference between the distributions of arrhythmic and normal type signals. EKG signals were selected from the database of the PhysioNet Internet resources, mid-big normal sinus rhythm database, EKG of the healthy people, 18 EKG signals, 2 EKG leads, sampling rate 128 gets, and mid-big supraventricular arrhythmia database, EKG of patterns with supraventricular To ensure comparability of the data, the same number of values were selected for each signal. The method for determining the variability of the time parameters of an electrocardiographical signal or the multilevel amplitude discrimination method is used for digital EKG signal represented by a set of values measured at certain time points samples. When analyzing EKG signals, it is necessary to ensure their comparability. Therefore, the signals must have the same frequency and time duration. Differences in the amplitude of the signals are eliminated by normalizing the signal values using the formula on this slide. The range of signal values is divided into a preselected number of intervals and the number of signals value falling into each of those intervals is determined. The Pearson criterion belongs to a group of non-parametric criteria independent of the shape of the sample distributions and allow to check the significance of differences between absolute or relative frequencies for two given samples. The implication of the criterion involves the formulation of null hypothesis about the absence of the differences between two given samples. In the study, the null hypothesis is assumed that there are no differences between the average histograms of EKG signal distributions of many healthy people and many patients with arrhythmia. Kolmogorov criteria can also be determined for difference between those two sample distributions. To apply it, it is necessary to calculate the accumulated relative frequencies for each distribution and then calculate the calculated value of the criterion using the formula in this slide. On this slide, you can see a histogram, the results of the method of multimodal discrimination can be used to establish differences between the EKG signals of normal and arrhythmic type. The results of applying the statistical criteria of Pearson and Kolmogorov criteria confirm the statistical significance for the distributions differences. Thank you for your attention.
Thank you very much. A little bit out of time, but thank you again. So now we're coming to talk number 12, Sachnikov Ivan, or another one who is co-author of this paper, number 12 again.
Okay, so my name is Ivan, and thank you very much to organizers for the conference, and thank you very much also for all others who make the reports today. And I represent Belarus State University and Faculty of Physics and Computer Technologies. So, and today I will make a very short intro to my report with the title Integrate the Semi-Supervised Model for Sparse Distributed Object Recognition in Multi-Parameter Data. And as a main domain area, we'll focus on remote sensing and aerospace image processing. And compared to the majority of cases where developing models on object recognition in urban environment with a very high distribution on the images of objects, for example, like multi-class classification and detection. So we will focus on sparse distributed object recognition. So there are a list of objects that can be related to this point, like dams, like expressway toll stations. We will focus on one of the representative examples as maritime vessels. So we call one-class classification and detection. So we will work with Airbus port dataset with 1.5 meter resolution and with partly annotated with segmentation masks.
so we made detection. Several points. First point is that the background was one class, yeah, but it is varied due to weather condition, due to some light conditions, and also the position where the object has been shot and captured. We have cropped tiles that then we use in training. Also, we have a list of extra different augmentations, like mosaic augmentation, cut mix, rotation augmentation, as well as flips. Yeah, and also about annotation, we have converted to random bound boxes because they will very well suit to our task. And about the model, so we use two stages. First stage, we classify task, classify tile, with object or not with object, based on ensemble of classifiers, modified version of DenseNet and TrustNet versions with a decreasing number of stride in first conf layer, and as well as less aggressive kernel size, and also average pooling set of max pooling. And the candidates that have predicted that they have object of interest, they have transferred to the next stage, to the detector. And as a detector, as a baseline detector, we used YOLO version 11, but more lightweight than a nano version. So we have used a decreased number of multiplier depths and channels, and in turn adjust the architecture. Also, as I said before, we use random bound boxes, and we have process training in 3 stages, each by 15 epochs, and we use progressive resizing. So we have increased the dimension of the image that we put to the network in order to increase the occurrence of detection, and it's worked well. As well as a final boost, we used 2 extra cycles of semi-supervised learning strategy, or in particular pseudo-labeling. About 15% of data in the training in these stages has been made up from previously from the test set without any labels, so that was pseudo-labels. And also here you can see our hardware baseline that we use in our model training. So what about the results? So we have made our results, and we have observed based on F2 metric that was averaged by a list of thresholds from 0.5 to 0.85. And here you can see that after adjusting the architecture, after introducing our, as you see before, extra number of augmentation and also 2 cycles of pseudo-labeling in semi-supervised learning strategy, we have achieved 0.92 by F2 metric. So what is also to add is that we'd like to, on the next stage, we'd like to scale our model to fine-grained object detection and classification. So we'd like to identify subclasses of maritime vessels or use another type of objects. And in longer term, we're seeking to apply it to object tracking algorithms, because in sparse distributed objects, it can be challenging in terms of object tracking. Yeah, sorry, that's it.
Thank you. A little bit out of time, but okay. Thank you. Let's give it an applause. And now we're coming to the next talk. Helena Artyom, number 13. Yes. Sorry if I'm spelling your name not very correctly. Number 13.
So, good afternoon, ladies and gentlemen. My work is about methods for reconstructing parts of training images from a pre-trained neural network. So, what's the problem? Suppose we have a neural network that was trained on a binary classification dataset. And the question is, can we get fragments of training images from the weights of the neural network? And if we can, how to do this? The first method studied in the work is a stationary method. This method makes an assumption that the neural network was trained till convergence. So it means that the gradient norm is 0. So we try to find training samples by minimizing the following objective, which means that we try to find samples on which the gradient of loss is 0. The second method can be applied only on neural networks which are homogeneous. It is a type of networks in which if we multiply the parameters by some positive constant, the prediction of the network will be multiplied by some other positive constant. And this method can be applied only for networks that could ideally classify the training data set. And if we have a such network, we can also try to estimate the direction of the gradient on the training samples and find the training images by minimizing the following objective. And the third method, it is a bit different from the previous two. This method doesn't make any assumptions on the architecture of the neural network, and the only assumption that we make that we know the initial weights of the model. And this method tries to estimate the direction of gradients as direction of difference of the weight during training. And we also try to find training samples by minimizing this objective, which means that we try to find training samples with that have direction of gradients the same as different of weights. So moving on to experiments. For experiments, NIST dataset and the dataset of histological images were used. So moving on results. The first method, stationary method, didn't yield any results, so it is not included in the presentation. The directional method yielded 36 reconstructions of training images from a simple homogeneous convolutional neural network. Also worth mentioning that the reconstructions are almost pixel perfect. And the other experiment was about not optimizing the objective in the pixel space, but in some other. For example, in the space of small images that then were resized to the 28 resolution. This method yielded some results, but as you can see, they are not as good as optimizing in the pixel space. And the third method, training simulation. For this method, histological images were used. And for experiments, ResNet 18 and vision transformer were used. As we can see, this method didn't yield pixel perfect reconstructions, but it yielded parts of the images from a training set. Also, there is lots of noise. The same applies to vision transformer, except for some artifacts due to its architecture. You can see some squares on the reconstructed images. So conclusions, the first conclusion that it is possible to get pixel accurate reconstructions of specific images from the training dataset from homogeneous neural networks. Also, it is possible to reconstruct images from training dataset from arbitrary neural networks if we know its initial weights. Also, the main conclusion is that the weights themselves do not carry that much information about training samples, unlike the gradients over them. So that's it. Thanks for your attention.
Thank you very much. A little bit out of time, but okay, let's give an applause. And so you're free now. And the audience like to draw some kind of impatient because it's not the all. We have two talks which are rest from the first lightning talk sessions. This was for some reason they're unable to give. So I'm addressing to online now. Markelov Vladimir, which is L19 talk. Please, are you alive?
Yes, I'm here.
Okay, so you have a floor, and I hope this time it will be done.
Is everything okay?
Yes, it's okay.
Good day, dear colleagues and participants of the conference. My name is Vladimir Markelov, and I represent Kazan Federal University, Institute of Artificial Intelligence, Robotics and System Engineering, and special thanks to my scientific advisor, Galerian Skander Gayazovich. Today I would like to share the results of our work on developing a multitasking control system for a small underwater robotic vehicle based on the STM32 microcontroller and the FAIRTOS real-time operating system. So why is this important? Remotely operated microclass underwater vehicles are becoming increasingly demanded. They are built in the inspection of hydraulic structures, in scientific research, and also in education. Current trends in digital transformation require such robots to be affordable, reliable, and easily expandable. And this is exactly the challenge our research addresses. So the goal of our project was to design a hardware and software control complex for a compact underwater robot capable of executing multiple tasks in parallel and maintaining stable operation in harsh conditions. So the main objective was to analyze the requirements for the control system and to design a suitable software architecture to develop a multitasking structure based on STM32 to implement software modules for motion control, remote control, commands, and safety functions, and to integrate peripheral devices such as ultrasonic sensors, cameras, servers, and into one single system. So what has been done? The architecture is built around the STM32F7 microcontroller with an ARM Cortex M7 core, where TOS ensures a clear separation of our functions, and several cores were defined. Remote control task for handling commands from the operator's console, DAC task for controlling clusters, camera tasks for operating cameras and the gripper linked to it, and sonic task for ultrasonic sensors. If you want, you can add some new tasks or recommend if they're out of use in your project. So the command interface was implemented via UART with data validation and connection loss handling. To improve reliability, the system includes fault tolerance mechanisms such as automatic surfacing in case of signal loss, isolation or critical errors, and continuous status monitoring. So about results. As a result, we created a system that controls propulsion, manipulator, and sensors simultaneously while remaining modular and easily extendable. This architecture opens the way to further automation of operations and the integration of additional sensors without redesigning the system. In conclusion, we developed a solution which demonstrates the efficiency of combining modern STM32 controllers and TOS in underwater robotics. The system proved to be fault-tolerant, flexible, and suitable as a foundation for future developments in this area. At the current stage, we have also created an educational robot constructor based on this scheme, which is now being used to teach children the basics of robotics and programming. So that's all. Thanks for your attention.
Thank you. So great time. Well, thank you to you. Well, and the next and last but not least speaker, which was also from the first lightning talk session. I hope he is also online. Gustav Yegor. Is it really? No, I see none. It means that we did everything what was planned, and I should say that all of you are super best. Now we are going to the afternoon recharge, so take some fresh air and return to the session B1. And by the way, I should say that all of young researchers who participated in lightning talk sessions are welcomed and strictly welcome to to closing session, because only this way you can achieve your goals if you will win the challenge. Okay, see you.
Machine and deep learning, computer vision and signal processing, artificial intelligence and neural networks, cloud computing technologies, and more. Pattern recognition and information processing, embedding the future. 17 conferences. 34 years of history. More than 1,300 reports. More than 4,000 participants. Innovative trends. Meetings of ideas. And more. Pattern recognition and information processing.
Of the session, I would kindly introduce Mr. Wu Yanfei. Yes. So he's a doctor in engineering, School of Electronic Science, and deputy leader of the National Standards Working Group, member of the Artificial Intelligence Group, Science and Technology Committee of the National University of Defense Knowledges in Changsha, and member of the Youth Expert Technical Group of Internet of Things in the China Institute of Electronics. And actually, so he has granted 11 invention patents and has awarded different kind of prizes and awards. For example, first prize of scientific technological progress of the Army, the special prize of scientific technological progress of Tianjin, and third prize of scientific and technological progress of national defense. So, really outstanding chairman we have, and there is a great honor that you agreed to manage this session. So, dear chairman, you have the floor now. Thank you.
Okay, thank you, Alex. Okay, ladies and gentlemen, good afternoon. So, welcome to our session 3. And for this session, we will have 8 reports. So firstly, I will welcome Adamovsky Igor. So let's welcome.
It's work. Hello, dear conference participants. My name is Igor Adamovsky. I am from Polsk State University, Republic of Belarus. My presentation is devoted to the implementation of smoke detection algorithm operating in real time on a single board computer, SBC. Actual problem of today, fire detecting at an early stage before it causes serious damage and we have time to react. There are different types of fire, and smoke is present at early stages of most of them. Thus, smoke is important and sometimes the only visual indicator of fire. This is true not only for early stages. For example, forest fire. From distance, smoke above trees will be visible, but flames will not. Traditional smoke detectors have a limited scope of application, low response speed, they are not adaptive, equipment installation can be expensive. The spread of video surveillance systems, closed circuit TV, CCTV systems, allows to be used them for smoke detection using computer vision algorithms. Such solutions are more versatile and faster, but they have some disadvantages. Hardware imperfection, optical system distortions, limited data for analysis. It's not critical, but this needs taken into account. The abstract scheme of CCTV contains several cameras are connected via switch to a recorder, which provides data to the operator's device. If a smoke detector works on the operator's device, it must process a large amount of data in real time. This requires expensive and high-performance hardware. Instead,
remote SBCS combined with cameras can perform the analysis. They have a low power consumption, relatively cheap, but they have few computing resources. The choice is limited. Usually for this tasks, Jetson Nano or Raspberry Pi are used. They have similar characteristics. Both are capable of encoding and decoding high-resolution video streams. Jetson Nano is more powerful and has NVIDIA GPU, but Raspberry Pi is a cheaper and more versatile solution, so we choose it. Let's move on to description of smoke. Its visual features can be divided into spatial and temporal. This classification is conditional because change in spatial feature over time is also a temporal feature. And temporal features are necessary. Smoke is complex object. We can't ignore it. First feature, upward movement of smoke particles due to the flame energy near it. Second, limited color range of smoke, as a rule from white to black. Third, partial or complete overlap of background objects, decrease in the sharpness. Fourth, relatively stable position of the smoke source. No, of course, it can move, but more slowly than other objects, for example, people or transport. And fifth, it's a changeable chaotic form, causing the flickering of the boundaries. Our problem has already been solved in various ways. For this, they used, for example, feature extraction based on local binary patterns, classification by convolution neural networks, rule-based motion detection and color segmentation, and light-wave YOLO models. The table shows that the most cases the processing speed is satisfactory, but the resolution of the input data is very small. I suspect it's because if you increase the resolution, the performance will critically drop. Low resolution, this may not be enough to detect weak or distant smoke. That's why we developed algorithm without neural networks, only classical computer vision algorithms. Our method identifies specific features and consistently refines the location of smoke in frames, if it's present, of course. The sequence of actions is as follows. Pre-processing, equalizing the brightness of channels. Next, selecting regions with stable motion and building a background model, MeOG2 algorithm. Next, select gray regions, thoughts HSV space. Next, selection regions that meet the regions of stable motion and color characteristic. These are candidate regions. Next, calculate preliminary range regions of interest based on candidate regions. Future analysis will be only for these regions. Next, selecting regions with a stable drop in the high-frequency energy components compared to the back model. Next, select regions with a drop in contrast compared to the background model. Next, select regions with a drop in high-frequency energy and contrast, both. Next, calculation refined region of interest. Next, selecting regions with stable upward movement based on Farnback optical flow. Combine all features to obtain a smoke region in the current frame, and the last, accumulation features and making a final decision on the presence of smoke in different regions of a frame. Based on experimental results, we obtained high detection quality. F-score is 97.5%, and false prediction is less than 3%. Algorithm was implemented in C++ with OpenCV library as part of a distributed complex based on Raspberry Pi 4 B model. Additional application was written in Rust language manager on the screen, which controlled the smoke detector, encoded, decoded AP camera HTTP video stream, and communicated with the client's model as a web application. To speed up the work, tasks were distributed to different CPU cores. The working model of the system is presented on the screen. Examples of the algorithm operations on various video recording are also demonstrated. We achieved a stable performance of 25 frames per second when processing any scene with resolution of 1280 by 720 pixels HD resolution. For more in-depth testing, we identify 3 modes. First, no load, no smoke. 2, partial load. Smoke appears rarely, occupies small area, or is absent. Smoke-like objects are present. And 3, full load. Smoke are constantly present and occupies a significant area of frame. We tracked the following metrics: CPU cores load and CPU temperature. First, core load. It's assumed that the lower and more evenly distributed between cores, the better. For mode 1, no load. Mode 2, partial load, and mode 3, full load. The greatest impact goes to core 3. Yes. It's okay. It's responsible for the last stages of the algorithm, which are active only in mode 3. And CPU temperature. The max temperature in Raspberry Pi 4B is limited to 80 degrees. In test, we achieved value reached about to 60 degrees. It's success. Let's summarize results. New algorithm for smoke detection in video is proposed for CCTV embedded models. Algorithm detects spatio-temporal features without neural networks, which ensure high processing speed. Algorithm is implemented as part of the video surveillance system in Raspberry Pi 4B model. Our solution demonstrated high F-score, 97.5%, and stable processing speed of 25 frames per second. Thank you for your attention. Ready to answer your questions.
Okay, thank you for your presentation. So, any question? Okay, I have a little question. Because you use the single board computer, so have you compared your work to the previous work? Like some date with the real time, what's the time delay or something else?
My English is not very good. Please, more slowly.
Okay. My question is, you mean the real time the real-time detection. So have you compared the date of the time or something else to the previous work with your method?
Is this a slide? I don't understand the question.
Okay, it's okay.
Sorry.
We will discuss later. Thank you.
Sorry.
Well, thank you again. So we come to the next speaker. His name is Wu Xiangyi. The report is target detection in remote sensing image based on improved YOLO by super token attention mechanism. So let's welcome. Okay. Okay, wait a moment. So we change to the third. The Russian handwriting recognition using VGG CDC transfer learning. So we have a little change. So let's welcome.
Hello everyone. Today we will speak our report, Russian handwriting recognition using VGG by LSTM CTC transfer learning. The report has 5 parts. First, project background. Handwriting text recognition is an important part of pattern recognition and artificial intelligence. Its main goal is clear. To turn handwriting text images into digital text. It can make it easier to edit and search. For example, all the documents and signed papers, if we can recognize them autonomically, we can save a lot of time and effort. The technology is already used in many areas, such as smart education, financial service. Second, experimental environment and this scale. Next, we use the PyTorch as a deep learning framework. We use CUDA to speed up training on GPU. The programming language was Python. For data, we use the public Sterling handwriting dataset. It contains real handwriting Russian synthesis. The dataset is divided into 2 parts: training set and text set. The writing styles are different. Some are clear and some have connected letters. This helps us test how the model works in real situations. Here are some simple images from the dataset. As you can see, different people write very differently. fifth, now let's talk about the model. We use the VGG STM CTC model. When we input a handwriting image, the model processes it step by step and gives you the final results. First, the VGG lacks the model's eyes, scans the image and finds key features like lines and strokes. Second, the Belarus LSTM takes its features and reads them as a sequence. It can remember what comes before and after each character, so it understands the context better. Third, the CTC turns output into readable text. The methods makes the model more efficient and practical. Here are my model parameters. Third, data augmentation and training. Before training, we process the data. We also use data augmentation to make the model stronger and more robust. The main steps are data augmentation. We exactly rotated, scaled, and distorted the images. They help the model handle different writing styles and angles. Third, the second, resize images. We keep the height at 32 pixels and adjusted the width. It makes all inputs the same size, so the model can process them easily. Third, count the tensor. We change the images into tensor format. This is what PyTorch can read. Fourth, normalize pixels values. They help the model train faster and more stably. These steps are very important. Then we help the model learn better and avoid overfitting.
Okay, next I will introduce the results comparison. From the picture, we can see that the yellow line and blue line are training loss value, and the green line and the red line are validation loss value. So from the picture, we can conclude that my algorithm shows better generalization ability by actively suppressing overfitting. Its small generalization gap indicates that it will perform better on unknown data than the original algorithm that has been overfit. The second one is the accuracy comparison results. From the picture, we can see that the yellow line is the original algorithm accuracy, and the blue line is my algorithm accuracy. Obviously, we can see that our algorithm improves accuracy faster throughout the training process, finally achieving higher accuracy. This shows that by using the cyrillic handwriting dataset and the data augmentation technique, our model achieves better performance on the Russian handwriting recognition test. And the other one is the total time comparison. The blue line is my algorithm total training time, and the yellow line is the original algorithm total training time. Obviously, we can conclude that its time efficiency gradually improves, and finally, it is slightly better than the original algorithm in terms of total training time. And this is conclusion. We can see that when we inputting the some Russian handwriting photos, the results are different. So by comparing the two results, we can conclude that through the data enhancement and transfer learning, the model achieved higher accuracy in handwriting recognition test. And last, I would like to sincerely thank Mr. Ma Jun. He helped us a lot for the project. Finally, thank you for your listening.
Okay. Okay, thank you for your presentation. I think it's a very good result. So, any question? Okay, we also thank you, Dr. Ma. Okay. Okay, let's go to the next report.
Thank you again.
So next, I think it is about the target detection, remote sensing, imaging based. Yes. Okay, let's start again. So your presentation is okay now? Yes. Okay, please come.
Hello everyone, thank you for being here today. It's my honor to be here to speak with you today. Today I will introduce our work, object detection in satellite images with enhanced Euro 11 based on super talking attention. This research aims to solve several in the field of object detection in satellite images. The technology of object detection in satellite images is a cornerstone for many key applications, such as urban planning, disaster prediction, intelligent transportation system, and has having scientific value. However, its task faces several challenges. For example, objects of varying size, clouding weather, this and small buildings. We are know that popular monsters now the two-stage model has a high accuracy, but is slow. The single stage model is fast, but has low accuracy. Of course, we need to face these problems. This paper proposes a method to enhance the Euro 11 detection framework, Euro 11 STA. This basic idea is introduced forward. It integrates the super talking attention module into the powerful Euro 11 framework. We integrate the STA module into the key node of the Euro 11 network, the P5 layer of the feature parent network on Euro's NIC. For input, super talking attention has three main styles: super talking sampling, super talking self attention, talking up sampling. STA divides the visual content into super tokens and perform self attention operation in the super talking space. There be effectively laying globe repetitions will reduce computation cost. We use the public available datasets. All experiments conducted in the same environment. The parameters are shown above. The experiment results are encourage the Euro 11 STA model perform better than other variants in the Euro family. This fully aligns with our designer goals. Compared with other attention models, the Euro 11 STA model still perform well. Within the results allows us to more clearly see the improvement. Our model is more accurate across different elements. In addition, we propose an object detection method based on the improved Euro network. This method combines REP cover, super talking attention, and NWD to more accurately detect the building in the images. Experimental results show that the model performs better in detect buildings. In the future, we will continue to work hard, improve the accuracy of object detection on more projects. Thank you for your attention.
Okay, thank you. So, any question? Professor Lee, do you have any question?
Okay, thank you. Can you briefly summarize the basic concept between the concept of the super token? I have no idea about the basic logic between these two.
I think it's a good attention. I don't.
Go back to your slides.
老师，我那个不太好说这个。哎呀，This is my network. 这个就加了一个检测头，非常简单。
One word, I don't know how to imply this attention to. Is it a mature tool in PyTorch or something? You can just inject this module into your network or something else. You must imply it with your coding yourself.
Yeah. I think it's same.
So it's already in PyTorch, okay? Okay, thank you.
Okay, thank you. Thank you again. Okay, let's move to the next presentation. The report is about the automatic identification and the quality assessment of potato planting rows using UAV imagery. Okay, let's welcome.
Hello, dear colleagues. My name is Ilya Mikhailov, and today I would like to share with you the results of our research project, automatic identification and quality assessment of potato planting rows using UAV imagery. Modern agriculture is moving rapidly towards digitalization, and precision farming is one of its key directions. Potato is a strategically important crop, and the uniformity of planting rows has a direct impact on yield. In parties, planting gaps common, they reduce efficiency. Traditional control methods, such as manual measurements and visual inspections, label intensive, subjective, and not always accurate. Our contribution is the use of YOLA 11 for plant segmentation, combined with morphological filtering and row alignment. This approach considers image resolution and agronomic parameters, which allows us not only to detect gaps and irregularities automatically, but also to solve practical tasks, such as analyzing machinery performance, assessing the quality of seed material, detecting abnormal zones in the field. The optimal platform for such monitoring is a UAV. It provides a centimeter level resolution, making it possible to detect even small deviation in row structure. Next, I will briefly describe the methods of data processing and analysis used in the study. The purpose of your work was to develop, implement, and experimentally validate and automatic methods for identifying and assessing the quality of potato planting rows from UAV imagery. The main tasks included creating and annotating the dataset, fine-tuning YOLA 11 models, implementing filtering, clustering, and gap detection algorithms based on ground sampling distance, and validating the results through comparison with manual annotation. For training, we used UAV images. In total, high-resolution images we annotated. They were then split into tiles to expand the dataset. To improve model robustness, we applied various augmentation. Finally, a quality control step excluded images with artifacts or with too few plants. In this study, we used YOLA 11 architecture, modern one-stage algorithm that combines feature extraction and object prediction. This makes it especially effective for agriculture monitoring. Key hyperparameters are shown on the slide. To evaluate the model, we used two metrics, mean average precision, F1 score. This metric allowed us to objectively compare different configuration and select the most stable model. All experiments were tracked with ClearML, which ensure transparency and reproducibility. We conducted a series of experiments with YOLA 11 models of different sizes, testing both the base version and versions with Mosaic Plus mix-up augmentation. The results showed consistent improvements with augmentation. For detailed analysis, we focus on YOLA 11M medium. We also tested different freeze depths and found that freeze equal 5 gap or gave the best results. Overall, all configuration we highly stable, which is comparable to recent research. This clearly shows that advanced augmentation improve both generalization and robustness. The training course illustrates this effect. With augmentation, the model research maximum performance faster and more consistently, which means better convergence. After processing, the model reduces segmentation mask. However, problem areas are small bridges sometimes appear between rows. The artifacts reduce the accuracy of subsequent row detection. To address this, we applied morphological filtering, specifically morphological opening with an adaptive kernel. The kernel size is calculated based on ground sampling distance and row spacing. This approach removes random bridges and noise, leaving only clean, continuous rows in the final mask. After filtering, the rows need to be aligned. To simplify analysis, we applied principal component analysis to the coordinates of the mass centers. The main orientation axis was determined, and the image was rotated so that the rows aligned vertically. This greatly simplifies clustering and row axis extraction. Row extraction was carried out in several steps: connect component analysis, detecting white regions and calculating their mass center, DB scan clustering, grouping center that belong to the same row, robust to noise and gaps. Median axis calculated for each cluster. The median Y coordinate was used as the row axis. Duplicate measures, close axis we measured using thresholds derived from row spacing. This algorithm is robust to noise and successfully identify rows even when gaps are present. To validate row detection, we compared the results with manual annotation. The accuracy was high, average angle deviation 1.8 degrees, position error 0.9, row detection 97.4%. Visual comparison confirms close alignment with manual markings. Difference appear only in shadow areas or invalid segments. Once the row axis was established, we performed gap detection. A gap was defined as a row segment where planes are absent for a certain minimum distance. For potato, the agronomic threshold is 40 centimeters. That means that only gaps larger than 40 centimeters were detected, which ensures practical value and avoids false detection. The accuracy of gap detection was validated on a manually annotated test set. We evaluated the system using precision recall and F1 score. The results were consistently high, confirming the effectiveness of the method even in heterogeneous fields. Visual analysis also showed correct detection of gap of different lengths. The main difficult accurate only in shadow or highly fragmented areas. To summarize the workflow, we developed a step-by-step algorithm that integrates modern computer vision and image analysis method. The diagram on the slide illustrates the main stages of the proposed solution. As a result, we developed comprehensive algorithm for automatic identification and quality assessment of potato planting rows. The methods demonstrated high segmentation and row detection accuracy, reliable gap detection, robustness under complex imaging conditions. It can be successfully applied in agriculture monitoring. In the future, we plan to integrate multispectral data and extend the algorithm to other crops. Thank you for your attention.
Okay, thank you for your presentation. I think it's a very interesting topic. So, any question? I think it's very useful in the agriculture. So, in your report, you mentioned the potato planting. So, can you use this method to another, maybe tomato? In China, we have a lot of rices. Is it possible to use your method?
Like crops?
Different plants, like, because you mentioned the potato, maybe we can use this method in rices different plants. Have you planned to do this work like the fifth, the application of, for agricultural monitoring, different plants?
Corns, например, какие еще? Excuse me.
Okay, maybe.
Пробовали ли вы этот метод для других растений?
Ну, если на русском можно, в целом
Better English, the answer.
перенести его на другие растения возможно, на те, которые как раз имеют посадку в виде рядов.
It can be used on plants that are planted in rows, so not only potato waste too.
Okay, I think it's very useful. Thank you. Thank you again.
Спасибо.
Okay, next speaker will be Sun Jiazhi. The topic is about the world's unified transformer for drone-based multitask object detection. So let's welcome.
Good afternoon, ladies and gentlemen. My topic is towards unified transformer for drone-based task object detection. My presentation will include 4 parts. Drones have gradually emerged and been widely used due to their characteristics of low cost, small size, and high flexibility. Object detection is a crucial task in applications such as the disaster search and rescue using drones. The combination of drones and object detection will be applied to more challenging tasks. The current deep learning object detection algorithms face many difficulties and challenges when applied in the field of drones, especially in terms of deployment on the edge side. The computing units on drones are limited, and the challenge of how to use limited resources to complete different tasks is also a major test. However, existing approaches typically design separate models for different tasks. While task-specific models remain a common choice, they suffer from several drawbacks. First, parameter redundancy and inefficient resource utilization. Each task requires training an independent model, leading to redundant parameters and suboptimal resource usage. Second, limited cross-model learning. Training a model specifically for a particular task will prevent it from learning information. So, in light of the above issues, it naturally occurs to us why we can build a unified architecture that unifies tasks of different modalities into the same model. The main contributions are as follows: 3 points. We propose a unified architecture capable of simultaneously handling visible thermal and visible thermal object detection tasks with a single model. Learnable task tokens enable dynamic modality adaptation without architecture changes and a simple adaptive fusion method. The baseline model for our work is a VIT-DT object detection model. When a single modality image is input into the network, it first undergoes image partition and linear projection, that is patch embedding, to divide the image features into multiple tokens. Then these tokens enter 3 transformer blocks for feature extraction. Each transformer block consists of 3 layers of window multi-head self-attention and 1 layer of global multi-head self-attention. The obtained features are input into the direction head, and the direction results can be obtained. This is the network structure of our work, in which three main modifications have been made. First, our model directly receives a pair of visible and thermal images, which are divided into three tasks: two single modality tasks and one dual modality task. Then we added an adaptive fusion layer after patch embedding to unify the dimensions of dual modality and single modality tasks. Finally, we added task tokens to the global multi-head self-attention layer to achieve the purpose of learning information between different tasks. Next, I will explain each part in detail. First, the visible and thermal image pairs are simultaneously input into the network, and the corresponding model images are selected for use according to the task. In the case of a single modality, visible or thermal images directly enter the backbone for operations such as feature extraction after being patch embedding. For dual modality, after patch embedding, fusion is first performed, and then they enter the backbone for feature extraction. Here, we use a very simple but effective fusion method. We establish two weight matrices with the same dimensions as those after patch embedding, which are multiplied by the corresponding positions of the matrix after patch embedding of the corresponding modality. The reason for doing this is that we can understand the weights as a weights between different channels of features, and our weight matrices can highlight the features of important channels. Next is the task token. We add the task token to the global multi-head self-attention layer in the transformer block. Concatenate the task token at the front of the features and then perform the attention operation. It should be noted that we use different task tokens in different tasks. The purpose of this is that during the training process, we can interact with the backbone parameters through different task tokens so that optimal performance be achieved in all three tasks. In our experiments, we utilized the drawn vehicle dataset to evaluate the performance of our proposed method. And we employ multiple metrics, including mean average precision, MAP at LU threshold 0.5, and MAP at LU threshold 0.75. We trained the model end-to-end on NVIDIA RTX 4090 GPU. VIT-DET was trained separately for each of the three tasks for 100 apples, with the best weights selected for testing. It should be noted that VIT-DET only supports single modality input. Therefore, in dual modality task, we add the fusion method mentioned in this work before training. Similarly, our work was trained for 100 apples, and its best performing weights were evaluated. As shown in table, our model outperforms VIT-DET in both MAP and MAP 75 across all three tasks, and our model achieves comparable performance to VIT-DET in MAP 50. From the perspective of the results, our model confirms that task tokens effectively guide cross-modality learning, enabling dynamic adaptation to different tasks without architectural changes. And our model effectively handles multimodal inputs with a single architecture, eliminating redundant task-specific training. Thank you for your attention.
Okay, thank you for your presentation. So, any question?
Thank you.
You have a question?
Thank you.
Okay, thank you again. So we still have 3 reports, but we haven't received the last file. Can you copy this? The last presentation. The last one. Okay, let's start the next. Next speaker will be Pershot Detomili. His report name is Segment Algorithm in Processing Satellite Images. Okay, let's welcome.
Good afternoon. My name is Khatinevich Artemy, and my research is segmentation algorithms in processing satellite images. The purpose of this research is to analyze existing methods in the context of solving the problem of segmentation of satellite images, select metrics that will show the effectiveness of the algorithms, and then compare the algorithms according to the selected methods. Experiment description. Real satellite images taken with equipment with a resolution of 2 meters were used as test data. The experiment involves 100 images of different surface areas. The original images were made in grayscale. The bit depth is 10 bits per pixel, which allows for more detailed images. 2 algorithms were selected for the experiment, the watershed and the flood fill. The goal of the experiment is to highlight water bodies in images. The metric for evaluating the segmentation methods will be the accuracy of the correspondence between the boundaries of objects in the original images and in the protest images. Based on this metric, the segmentation algorithms used in the experiment will be assessed in terms of their suitability for solving tasks. The first algorithm is watershed. Experiment starts with finding an approximate estimate of the water objects. For that, binarization can be used. Binarization is the process of setting a certain brightness threshold and then assigning each pixel either the value 0, that means black when the threshold is exceeded, or the value 255, which means white color when the threshold is lower. Next step is removing any small noises in the image with the using morphological opening. This is a process erosion followed by dilation, and removing any small holes in the object with using morphological closing. This is process of dilation followed by erosion. The remaining regions are undetermined as either water object or background. The watershed algorithm is employed to resolve these ambitious zones. Flood fill is an algorithm to identify and change adjacent values in an image based on their similarity to an initial point. This method is used to highlight areas of uniform color. To perform this algorithm, an initial pixel is selected and the color change interval of neighboring pixels relative to the original is set. The process combines pixels into one segment by filling them with one color, provided that they fall within the specified range. The result is a segment filled with a certain color. This algorithm is useful for filling areas with a slight color difference and a uniform background. The flood fill method satisfactorily solves the task of finding the boundaries of water bodies. The algorithm relatively accurately identifies small details, such as land areas located in the middle of founded segments. The main disadvantage of this method is the need to implement the search for the coordinates of pixels that will be located on the necessary clusters. The solution is either human intervention as an intermediary between the processes of data collection and data processing, or introduction of an additional algorithm that will identify the necessary segments. Another disadvantage is that if this method encounters contrasting obstacles during its operation, then the cluster, which is one object in the original image, will be selected incorrectly. The watershed method can, under certain conditions, create redundant segmentation. That means that places that should be a single cluster are divided into many smaller subclusters. This defect can be detected by examining the image with markers, but unlike the flat fill method, the watershed algorithm doesn't require an intermediate stage in the form of searching for the required coordinates on the image. And at the same time, this method, with correct choice of initial parameters, doesn't experience bigger losses in the accuracy of objects in comparison with flat fill method. As mentioned earlier, the algorithms were compared according to the metric of accuracy of the object boundaries in the original images and the images after processing. This implies that objects in the original image are taken as a reference, and the results of the algorithms are evaluated by the percentage of match reference objects with the selected segments. Average level of accordance with the standard with using the flat fill method is 85%. But during the experiment, additional assistance was required to find objects in the image and transfer the coordinates to the algorithm. On the other hand, the watershed algorithm showed a match rate 80–82% without the need for additional assistance. The problem of additional assistance for flat fill algorithm will become critical if it becomes necessary to create a fully autonomous system for analyzing satellite images. From the information obtained, it was concluded that when comparing according to the metric chosen at the beginning of this experiment, the watershed method would be preferable. This method has the advantage of not requiring additional image pre-processing while maintaining the same level of accuracy. After a study of the algorithms in the context of the satellite imagery processing task, it was concluded that the watershed method is advantageous in the general case. But it's also necessary to pay attention that space photography is a process with a large number of unstable conditions to which it's constantly necessary to adapt and minimize their consequences. Therefore, the optimal choice when solving image segmentation problems is a combination of some algorithms for each of them to perform the segmentation stages in which they cope best. Thus, the decision on use of each algorithm must be made based on the specific of the task and the conditions for obtaining each image. Thanks for your attention.
Okay, thank you. Thank you for your presentation. So, do you have any question? I think it is very important because in China we often have the heavy rain and they will be dangerous for the rivers. If we have this method, we can to solve these problems. So could I have a little question about the accuracy? So in your presentation, you mentioned the accuracy. Please go back.
The accuracy of watershed method was 85%, and the accuracy of flat fill algorithm was 80–82%.
Yes.
As I remember.
How did you calculate the accuracy?
I mentioned that we have a metric like correspondence, accuracy of the correspondence between boundaries of objects in the original images and images that we got as results of our experiment. this axis of correspondence is a metric. This is a percentage.
Okay, thank you. Okay, let's move to the, okay, thank you again. So we move to the next speaker, Zufsky Yevgeny. And the report is about a PCA-based approach for dynamic yellow chromatophore detection in cuttlefish skin. Okay, let's welcome.
Hello, listeners. My name is Evgeny Zhukovsky, and today I will tell you about the PCA-based approach for the dynamic yellow chromatophore detection in cuttlefish species. For example, its skin. As for those who don't know who is the cuttlefish, there is a picture of it right here. So a little bit of theory about the cuttlefish. As all the cephalopods, they have the special mechanism to mimicry for the environment, and this is caused by the so-called chromatophores. Here is the video of how it mimics using its chromatophores, and actually they change color due to the radial structure of muscles that surround this cell, and as they contract, the cell grows or decreases in its diameter, so it becomes like darker or lighter. And also it's controlled by the neural mechanism from eye to skin directly, and there is one thing about its eye that's many scientists, they think that the cuttlefish is blind, it's colorblind actually. And the way how it changes color without understanding this color is the first question we raised when we decided to conduct these experiments. So what's the significance actually of doing research on yellow chromatophores? As first of all, these regulatory mechanisms of yellow chromatophores, they have actually they're very significant, as well as the black chromatophores that we mostly see on the body. Thank you. While we think that black chromatophores are responsible for the pattern formation, the yellow chromatophores could be responsible for the overall hue formation and also its modulation, as for the background of the skin. And the second, we propose that developmental considerations regarding the chromatophore control is that the black chromatophores are actually the later stages of the yellow chromatophore development. As you can see here on this picture, we conducted investigation, and as it's shown, mostly yellow chromatophores, they move through the stage of red chromatophore and turn black also. But if the black chromatophore actually has a different function from the yellow chromatophores, so then how the neural lines are actually connected and reshaped in the brain of the cuttlefish, so that was the ultimate question we raised. So this is the experiment design. In briefly, we first of all have to decide the standardized method for taking the input pictures, and we decided just to record straight on its back. Actually, the black one is the electrode. We did the input electrocution of the brain. And here is the information also, but it's more for biologists maybe. So, like, these are the input images and videos actually we've collected and gathered on this experiment. Here you can see this is the video in which we electrocute the brain with a little interval of the electrocution. And this is the image we mostly work with. It has it captures almost all the body of the cuttlefish, and that's how we can determine the areas, specific areas, for example, the straight back area or its left or right area. So what's the neuronal response? Actually, here you can see this graph is for the neuronal response. We use the special calcium dye to image the response from the brain directly as it, sorry, it's with the sound. This is the graph that shows the brain response and the brain activity as it changes the chromatophores on the body. So was the color analysis actually, here you can see this, the color coordinates we have for gray and for yellow. These are the components we chose to investigate. And they also, they're kind of good for distinction in between each other, but it's only for these pictures. Mostly we have pictures as I shown in the previous slides, and there is a background that is kind of yellowish, so that's why it's hard to determine the yellow chromatophores. And yeah, so that's why we need to take good stated pictures. Here is the color diagram. We used mostly the HSV colored coordinates, as we can distinguish the yellow and dark colors here, as you can see. And what we decided to do is also segmentation of yellow ones. And as you can see, the yellow ones, they are mixing with others blobs here, the chromatophores, and they form the background image on the skin. So we're moving to the detection algorithm. We decided to use the PCA algorithm, as this approach has inherent robustness for the non-uniform elimination of our organisms, and by focusing on our PCA, we can separate the algorithm from susceptible changes in it in lighting conditions. And that's why it makes it suitable for capturing such biological phenomena in uncontrolled or semi-controlled environment as we had. So these are the components. We did the PCA analysis with 3 primary components here. And as you can see, mostly the third component becomes very noisy, and we usually take first or second component as the main ones. And here we have the pair plots of these images and also the PCs. Here the information retention, as I said, we used mostly the first primal component here. And after we did the PC analysis, they are mostly centralized here, as you can see on the pair plot of the PC, not as like the band images. Here is another image that was shown previously as the example image here. You see it mostly extracts the background. That's why we mostly have had problems with the extraction of the chromatophores. And here is also the diagrams of pair plots and information retention. And here, after we did the PCA analysis, we can compose the images we've taken after the PCA. And here, as you can see, we can distinguish the yellow chromatophores against the black chromatophores, and mostly important against the background, as it's skin itself. The yellow chromatophores come, after all, they come more darker, and that's how we can also measure them in terms of quantitative data and qualitative data. And in conclusion, this detection and analysis, it represents a vital area of research, I think, because this understanding helps us to create the biological camouflage create the camouflage, and also to inspire the novel adaptive technologies, so in terms of biomedicine and other researches that are done with biology. Thank you for attention.
Okay, thank you for your presentation. Very interesting work. So, do you have any question? Okay. No. Okay. Thank you again. So we come to the last. The name is about approaches to the printed circuit board defects detection. So let's work on.
Good evening, dear colleagues. I'd like to present you the report on the topic approach to the printed circuit board defects detection. So, an important problem in the production of electronic equipment is the quality control of PCB at various technological stages. In this case, the object for control is a PCB image or its photo template. The elements in a PCB image are contact pads, conductors, reference points, and service information in the form of letters and numbers. A defect during the inspection implementation is a deviation of the topology elements on the object from the design documentation due to manufacturing errors. For example, inconsistencies in temperature and time modes of production. The task of PCB defects including finding is relevant due to such trends in the design and manufacture of PCB as the macroelectronic components miniaturization and the high density connections usage, the introduction of flexible and stretchable circuits, the use of new materials and manufacturing methods. So here you can see the proposed methods. Let's examine them in details. So first is a reference-based PCB inspection algorithm. It is as follows. First, the image is pre-processed, which consists of binarization, noise removal, correction of scale and rotation angle to align the pair of reference and the analyzed image. Next, the defects are searched using the exclusive OR operation, and then the defects found are classified according to the binary flags and their geometric parameters are determined. The next is the YOLO of version 8 model. So it is a modern model for image classification, instance segmentation, and object detection without anchoring, developed by Ultralytics. The development of object detection idea is the introduction of an extra angle for bounding boxes to take into account the orientation of desired objects and in an image. This approach is called oriented object detection, and it is obvious that bounding boxes are also oriented and simply called OBB, oriented bounding boxes. So the YOLO, for YOLO 8 version 8 model, one OBB in markup files is described by class label and normalized coordinates of all corner points. The next is hybrid approach. It is a combination of the above methods. So due to some imperfection of data sets and above models, methods, it is proposed to use them simultaneously. So the main idea of this method is to choose one of them due to the quality of images in data set. It is recommended to use the reference-based PCB inspection algorithm, which allows to classify all found defects into 6 disjoint classes to search for defects in high-quality images when reference is available. When reference is not available, it's recommended to use a YOLO version 8 model. So in the first part of the experiment, the YOLO of version 8 model of size nano pre-trained on the COCO dataset was further trained and tested on the deep PCB dataset. The experimental results presented. So this is the example of detection with this proposed method. And the result of the detection by different methods is in this table on the screen. So the results show the high accuracy, mean average precision. Sorry. So it's almost the best method available in the open press. In the second part of the experiments, the PCB defect data set was used. Also, the YOLO of model, the YOLO of version 8 model of size nano. The PCB inspection reference-based algorithm uses structuring elements of size 5 by 5 and different methods like the scale invariant feature transform, sift, and so on. So this is the example of detection by this by the proposed method. And here our method provides the best result in the open press. It is 99%. So in the conclusion, I'd like to say that there is a global trend towards the use of one-stage detectors and their lightweight versions, which provide a balance between accuracy and speed, which is important for real production with product inspection in the pipeline. Such models use compact backbone networks like MobileNet and FasterNet, lightweight convolutions, and optimized loss functions. To increase sensitivity to small and complex defects, special and coordinated attention models are being actively implemented, as well as pyramid structures for combining features at different scales. This allows models to work effectively with defects of various sizes and with a complex background. Transformer-based architectures like Deter and real-time Deter are beginning to outperform classical CNN in accuracy and speed in defect detection tasks, especially when it's necessary to take into account complex relationships between objects in the image. The proposed YOLO version 8 of size nano model, further trained on specialized datasets, demonstrates the MAP 50 values of 0.98 and 0.99 on the corresponding test sets, which is comparable or exceeds the best global results. Thank you for attention.
Okay, thank you. Thank you for your presentation. So, anyone have question? Okay, I think it's very interesting work. I have a small question about you mean the defects of the PCB. So in your experiment, how many defects have you found? And maybe which one is the most defect normally?
There are 6 classes of defects, but in a single image there are about 3 defects of one type, but in the whole test set, I don't remember, it's about 20,000 defects, something like this.
So it depends on which part. Maybe you have different ICs.
So one image, in average, contains about 6 defects of different types.
Okay. So normally like the short and the open one and short, different.
Open, short, spurious copper, mouse bite, and island, as I remember.
Okay, thank you. I think because this is a simple PCB, maybe with different types of PCB, there will be different defects. Okay, thank you for your work. Okay, we will close our session. In this afternoon, our session is very interesting because it includes the smoke detection, the remote sensing images, and also for the handwriting and also agriculture different areas. So we will close this session. And the next session will begin at 18. So thank you for your attention and thank you for all the presentators. Okay, thank you.
Thank you, Mr. Chairman. Thank you.
history. Where the echoes of the past meet the dawn of the future. A place where vision is molded into substance. Pattern recognition and information processing. Now is time to come.
Is not finished yet, and I want to remind you about that in our flash session we have only 5 minutes for your presentation. And I would like to present the first speaker, Mosova Elena.
Dear colleagues, today we present to you a report dedicated to a modern and rapidly developing method for solving problems is mathematical physics. Physical informant neutral network or PIN. Physical informant neutral networks method was proposed in 2019 by a team of authors. It represents a deep learning framework for solving both forward and inverse problems described by non-linear partial differential equation. Logical question arises: why is a new method needed when there are time-tested classical grid-based methods such as the finite differential method or the finite elements method? Firstly, classical methods are often inferential or extremely computationally expressive for complex non-linear problems, especially in high dimensions. Secondly, this is graven did for universal computational approaches that can flexibly work with various types of problems. Thirdly, and this is a key point, PIN is particularly well suited for solving inverse and ill-posed problems, which are widespread in geophysics, material science, and medical diagnostic. Traditional methods often struggle with such tasks. Let's take a closer look at the operating principle of PIN. Approximation by a neural network takes the coordinates of a point, spatial and temporal, as an input and output, predicting value of the thought function at the point. Parameter training, the learning processes, is not about memorizing data, but about fitting the network's parameters to satisfy the physical laws, the equation, and the problem's conditions. The essence of the approach is as follows. The unknown function with the solution to the equation is approximated by an official neural network. The parameters of this network weights and bases are optimized not based on data, but by minimizing special loss function. This is functions including the equation residual, how well the network proposed solutions satisfy the original differential equations. The boundary condition residual, how well the solution satisfies the condition on the domain boundaries. The initial condition residual for now stationary problems. Thus, the physical laws written in the form of equation are embedded directly into the neural network training process. Mesh-free, this is one of the main advantages. The method does not require discretization of the computational domain with a complex geometry into the mesh. The point at which the loss function is calculated can be close arbitrary. They often generated randomly through the domain. This elementary our dependence of mesh generators and provides great freedom for working with complex geometry. Where does PIN fail to train? Despite its advantages, the classical PIN method has its own problem. It can train poorly or fail to converge for certain classical F problems. This is often associated with the cause of dimensionality and the complexity of the loss function landscape. So a PIN for this future encoding modification have been proposed that solve this problem. One of them, the adaptive weighting with increasing the weight of the loss function at point with high residual. Another is Fourier future encoding. Example, convection diffusion equation. To demonstrate the effectiveness of the approach, the presentation including an example of solving convection diffusion equation for comparison a solution obtained by the classical finite element method is show which reduced the use of iterative auto-adaptation algorithm for the mesh based on solution gradient to achieve accuracy. Next, we see a comparison of the training processing for classical PIN and its proved version SAR PIN. The graphs clearly demonstrate that the modified methods converge faster and to lower error. SIPIN plus FFT or SIPIN or PIN. This slide expands the comparison by adding the SIPIN plus FFT methods. A combination of the adaptive approach and Fourier encoding. One can expect that this hybrid approach shows the best result and the fastest converges among all the methods considered. And let's summarize and highlight the key advantage of the PIN approach. Operation of arbitrary sets points. Compute freedom from a mesh simplified problem setup. Solving non-linear problems without linearization. Unlike many classical methods, PIN does not require linearization of complex equations. Unify framework for forward and inverse problems. The same algorithm can solve both forward problems and inverse problems. This is a powerful and unified property. High-defined complex domain geometries. The absence of mesh allow for easy work with domains of any shape. Relatively low computation.
Time is out. minutes ago.
Thank you for
Can
attention.
you finish? That's all or not? That is all?
That's all. Спасибо.
Thank you very much. Thank you very much. Are there any questions? Thank you. Can you please give a particular example of how do you use to solve real-world problem with this approach? The examples was model. We see the model examples, but not the real world examples. Спасибо. Okay, we have no time. I would like, thank you very much. I would like to announce the next speaker, Vadim Zakharyev.
Нет, есть, да, все должно быть. Good evening, dear colleagues. My name is Vadim Zakharyev. I'm from Belarusian State University of Informatics and Radio Electronics. And I would like to present our work on a hybrid voice activity detection and speaker gender separation model. This model represents a step forward in our research for on-device processing, enabling effective in privacy-based speech analytics. Modern smartphones and voice assistants require effective, privacy-focused speech processing without cloud dependency to minimize latency, energy use, and privacy risks. The following components are integral parts of audio processing pipeline in a modern voice virtual assistants. Voice activity detection distinguishes speech from noise using temporal dynamics and spectral patterns. It is essential for detecting user commands in noisy backgrounds or tracking dialect states. Speaker gender recognition optimizes system by adapting to vocal differences, such as separating gender in multi-user settings or adjusting assistant responses based on physiological cues like pitch, for example. Combining VAD and VGR saves compute power, critical for on-device AI. This challenge is handling noise environments with above 5 decibels with SNR in real time without speaker enrollment. And our goal, a hybrid model fusing deep neural network for joint tasks with under 3 million parameters with, and 15 milliseconds latency response. Traditional WAT approaches such as statistical methods based on energy threshold or zero crossing rates struggle with device noise conditions like, for example, crowd noises or scenarios with low signal to noise ratio. Neural networks alternatives
improve accuracy, where learn patterns, but demand high compute and unsuitable for mobile CPUs. Gender classification methods, like, for example, Gaussian mixture models or MFCC or deep embeddings, achieving high accuracy on clean data, but perform drops in noise below 10 decibel SNLs due to weak feature extraction. Joint WAT and gender recognition models are limited, often rely on cloud processing and heavy feature engineering, with pure noisy scenarios handled without enrollment. Our hypothesis builds on efficient architecture such as SyncNet for raw waveform filtering, WAV2VEC for self-supervised embeddings, and distal Hubbard for compression. At the core of our now compact audio embedding network, a lightweight foundation with about 500,000 parameters. It extracts 64-dimensional embeddings from end-to-end raw audio frames, using for about 50 megaflops per frame real-time on mobile SoCs like Snapdragon 855, which is commonly used for mid-tier smartphones. CAM consists from next blocks as sync convolution block for frequency selectivity, mimicking bandpass filtering, one-dimensional convolution neural network backbone for capture local patterns, transform encoder for contextual encoding, and finally a projection layer for compact output. The full multi-branch DNL totals have for about 8 million parameters, post-distillating, including CAM. The full processing pipeline also includes such layers as spectral branch, which has two-dimensional CNN, treats embeddings as pseudo-spectrograms to capture noise-robust frequency patterns. Temporal branch, which is BLSTM network that model sequence dependencies for speech continuity in a WAT and pitch variance in gender. And fusion layer to concatenate branches outputs to a shared dense layer, and to softmax two output layers for binary classification and gender classification. Additionally, we are using techniques like knowledge distillation from a larger teacher, like a combination of ResNet plus transforming using KL divergence plus task clauses, and int8 quantization with per channel scaling reduce memory to 75 megabytes of RAM. And we used LibreSpeech dataset for self-supervised pre-training, making 15% frames and reconstruction spectrogram with ADAMV optimizer. Time is over, yes? Okay. The results are presented on the next slide. As my final words, I would say that we have relatively good results. Our model scores is about 95 and 2% of that F1 metric overall. And for gender accuracy, we get for about 97.5% accuracy. Okay, that's all. Thank you very much.
Thank you very much. Please, one question, please, if you have. No questions? Okay. So please give a few words about different type of models. So it's about different types of input features or something else? No, on the slide with the results. So what is the main difference between these models?
The first column is our proposed embedded model, yes, for WAT and for joint WAT and gender recognition. The other, it's baseline models, different baseline models. Yes. Like Celery WAT, it's a commonly used models. It's open source. It's well documented and available in source code. The other approaches was used as baseline to compare results
with our embedding model and without it.
So I really don't understand what means that the model type MFCC plus 4 months. What is a neural network or something?
Yes, it's the same architecture for all architecture, but for embedding layer, we use not our KM framework, yes, that we propose. We use baseline methods like
ordinary feature extraction method.
Yes.
Okay, thank you.
Okay, thank you.
Anastasia, are you ready?
My name is Sergey Dolenko. I'm the last
speaker. Okay. Please, let's start.
Thank you. My talk is about use of variation autoencoders to enhance the representativity of experimental data. We work at the example of an inverse problem of spectroscopy on determination of concentrations of 8 inorganic ions in water aqueous solutions by spectroscopic methods, by optical density. Now, general challenges in acquiring spectroscopic data sets, in particular for inverse problems solving with machine learning, is that the experiments are laborious, expensive, and time-consuming, and obtaining a representative data set requires a substantial amount of data. So to minimize the costs associated with increasing the data set, we try to use artificial generation of data. Usually science community, computer science community uses data augmentation techniques. However, the most common approach is here, adding noise, using interpolation or using open resources, encounter some difficulties, which in this case makes using these approaches nearly impossible. So another approach is to try generative neural networks to obtain additional data based on the relatively small data set obtained in experiment. So this is the motivation of this study. Generative network approaches may be divided into two groups based on generative adversarial networks and based on variation autoencoders, either common variation autoencoders or conditioned, while and also they concentrate the target values for common variation autoencoder. They estimated either in the initial space or in the latent space of the wire. We tried both these methods in this study. Reference solutions for the inverse problems are obtained by training regression neural networks on experimental spectra. We have a separate network for each ion, so in this case 8 separate neural networks. Now this is the variation autoencoder, quite a well-known thing. I will not tell about it here. Most of you know what is this. And expanding the data set using wire is as follows. First, we train regression networks for each ion on experimental data. Then we train the variation autoencoder. Then we use the other part of the wire to generate additional patterns so as to double the size of the training data set. Now we determine the target concentration of the ions in generated patterns using the regression models trained here on step 1. And finally, we use the double training set to train new regression models to solve our reverse problem. The condition Y is different from conventional Y by the fact that we apply target values also to the input of the decoder from the latent space. Expanding the data set with conditional Y looks as this. We train CY on experimental spectra, then we generate patterns using CY to double the size, and finally we use the double training set to solve our reverse problem. Parameters of the computational experiment: if we compare Y generated spectra with experimental ones and also with CY, we see that they are very similar. Now, as for the results, extension of the training set allows us at least to not to have a decline in solution quality. The CY for the same purpose increases errors, but common Y allows us to obtain a small decrease in the errors, especially if we generate additional data, not from normal distribution, but from Unicode distribution. These are slight blue columns. The conclusion is that the approach in the whole seems promising, but we need some further research for the optimal distribution of patterns in the latent space of Y, also in the space of target variables, and also we need to find the optimal way to normalize input features when training. Thank you for your attention.
Thank you very much. Please ask question. Okay, Sergey, I have a question. Which is primary task what you solve?
Our primary task is to obtain efficient data based on the experimental data, but not coinciding with it. And to do so, we need to model the distribution of experimental data in the latent space of the autoencoder, so as the generate data will edit generated data to the data set could provide reduction of the error. Now the effects quite small, but we hope that finding the due parameters of the system would allow us to improve the solution of the reverse problem.
Thank you. Okay. We will go to the next. And the next presentation and speaker Alexey Rожнов.
Добрый вечер. Меня зовут Сергей Тюрин. Я позволю себе краткое вступительное слово на русском, после чего мы посмотрим видеопрезентации доклада. Я попрошу включить. Я являюсь главным редактором Роскосмос Медиа. Это центр внутренних и внешних коммуникаций, часть Центра внутренних и внешних коммуникаций госкорпорации Роскосмос. Мы занимаемся как медийный отдел освещением трансляции запусков ракет, а также популяризацией достижений ракетно-космической отрасли. Пожалуйста, все внимание на экран.
Dear
colleagues, this combined report by the team of authors is presented for your consideration. I am Sergei Anatolievich Turin, an employee of Cosmos Media, and I will be presenting Dear colleague, transport system address provided on this slide in preparation for our participation in the conference. The goal of the project is to conduct exploratory and applied research on the integration of data management in the creative industry. This will help to develop new and modern technologies. Dear colleagues, this combined report by the team of authors is presented for your consideration. I am Sergei Anatolievich Turin, an employee of Roscosmos Media, and I will be presenting it. Now then, an exploratory study on psychoacoustic technologies for intelligent transport systems. A preliminary assessment of efficiency and data management. This is the title of the reference report, which was previously published in Russian and can be found at the address provided on the slide, in preparation for our participation in the conference. The goal of the project is to conduct exploratory and applied research on the integration of data management systems in the creative industry. This will help to develop advanced, new and modern technologies for intellectualization in the future. The research will be based on real-world experiences from the creative industry, which will provide a practical basis for the research. This study investigates the integration of psychoacoustic aspects into the early development of intelligent transportation systems. It examines the viability of employing methods to pre-assess the efficacy of exploratory research and data management. The foundation of this approach lies in the integration of data envelopment analysis with the various performance evaluation models. The report also includes an accompanying presentation on applied achievement in the field of communications showcased at the Lightning Talks session/flash session. The research highlights important parts of creating and using hybrid models of data envelopment analysis, looking at new trends in smart information processing for better proactive sound design in future transportation systems. For the sake of our distinguished audience, I would like to address a number of comments. Позвольте для уважаемой аудитории перейти к ряду следующих комментариев. Data Envelopment Analysis как инструмент аудита в этом приложении рассматривается для оценки качества распознавания, формулировка на которой фокусируется внимание. В обязательном порядке человек есть то самое звено, устраняющее различного рода нештатные ситуации, посредством донастройки качества реализации разнообразных процессов обработки информации. По сути, известно и ранее, а в той или иной степени присуща инженерному видению в ракетно-космической отрасли, преимущественно для пилотируемой ее составляющей, быть может, за исключением полностью автоматических средств. Поэтому стремление противопоставить в общем подходе известным тенденциям разработки современных технологий распознавания каким-либо образом тут нет. Скорее, это может иметь отношение к настройке прикладной системы с применением соответствующих технологий оценки эффективности. Упреждая ваши уточняющие вопросы, звук тут для транспорта – это для нас аспекты безопасности, добавленной стоимости и некоторых инклюзивных решений. Наиболее упрощенный пример, соответственно, по ним дополнительная озвучка при движении малошумного электротранспорта, как иллюстрация, имитация звучания двигателя для отдельных потребностей водителей в салоне тех же электромобилей, а также частные вопросы по предупреждению травмоопасных конфликтных ситуаций для малоподвижных, слабовидящих пешеходов. На нашей с вами подсекции доклады ограничены 5 минутами, поэтому позволю себе акцентировать внимание только на основном. Речь здесь прежде всего может идти о наблюдениях по аналогии с практикой деятельности для маркеров дискурса во взаимопонимании. Учитывая, что у нас имеется возможность раскрыть содержание 2 последовательных докладов, рассматриваемая нами предметная область интеллектуальных транспортных систем включает также автономные робототехнические комплексы. На представленном слайде показан вид титульной страницы постоянно действующего семинара. Кстати, слева как раз вот еще было у нас объявление о данной конференции, а также кадр из предшествующей апробации смежного вопроса освещения отечественных и зарубежных достижений робототехники, киберфизических систем и других перспективных интеллектуализированных технологий в современных средствах массовой информации. Моя же роль, в свою очередь, заключается в апробации данного передового инструментария при рассмотрении новых возможностей его применения в прикладных задачах управления данными, в примерах локальных задач деятельности для медиастудии. So, applied issues of experimental media content synthesis, system integration of tasks, and evaluation of information processing efficiency. The service links are also shown on the slide. The preliminary results of exploratory research on the substantiation of hybrid models of data envelopment analysis technology, mainly in the field of media and communications, are presented. The main focus of the interdisciplinary research is to find innovative solutions for creating experimental media content using specialized information systems. The substantiation of the related tasks of advanced data processing is carried out in the context of promising applied issues of synthesis of integration components of linguistic support. As in the previous report, let me draw your attention to the most interesting findings. Как и в предшествующем опорном докладе, позвольте акцентировать ваше внимание на наиболее интересных первичных результатах. Основной совокупный результат, который может быть вынесен на обсуждение, это, по сути, в первую очередь реализация новых возможностей пополнения опыта в единой номенклатуре, как составной части инструментария анализа среды функционирования по мере выявления и накопления прецедентов в специфических условиях. Во-вторых, экспериментальные соображения по коррекции и перестроению смешанной рейтинговой оценки с частично противоречивыми локальными критериями в условиях нетранзитивных предпочтений и наличия сложно подчиненных манипуляций, например, с одновременным использованием так называемых лайков и дизлайков. В завершение совокупность элементов информационно-лингвистического обеспечения в терминах дистрибутивной, то есть распределительной семантики для обеспечения междисциплинарного моделирования и эффективной реализации ряда интеграционных компонентов инновационной платформы, профессионально ориентированной социальной сети с формуляцией маркеров дискурса. Таким образом, несколько отдаленные, но в то же время вполне обозримые и в принципе реализуемой перспективой является дальнейшее совершенствование научно-методического аппарата с учетом опорных сценариев развития проблематики и прогнозного моделирования, даже передовых достижений в целях сопряжения нейроинтерфейсов и биологических нейронных сетей. If necessary, the content of the reports can be provided in English. Конечно же, этот стоп-кадр не является экспериментальным контентом, а самым, что ни на есть, непосредственным эпизодом интервью с Мариной Витальевной в Национальной академии наук НАН в прошлом году. Большое спасибо за внимание. Если таковые есть.
Нет. No. Thank you. Any questions from auditory?
Спасибо.
So please tell us, what is psychoacoustic technologies and what do you mean by that?
Ну, в данном случае я позволю себе на русском, если возможно, да. В данном случае это система, которая необходимо, может быть, находиться в разработке. Ну, собственно, в примерах на слайде там было указано. То есть, в первую очередь, это малошумный электротранспорт. Когда мы переходим на электрические автомобили, и действительно необходимо подзвучивать, тем более для инклюзивных относительно групп граждан, которые могут, ну, то есть привычно человеку слышать звук моторного двигателя все-таки, да, и поэтому вот в транспортных системах будущего это необходимо будет рассматривать изначально на этапе проектирования.
Ну, просто почему психоакустические технологии? Вот. Именно слово вы такое использовали достаточно.
Проактивно-акустический дизайн, либо, да, психоакустические технологии. Но это больше связано, да, с психофизиологией, получается.
Хорошо, спасибо.
Спасибо.
And, another question, have you mathematical models for describe your approach?
Метрические, что-то оцифрованное или да, вы спрашиваете? Нет.
Yes.
Ну, в данном случае основной результат, он действительно сводится к пополнению базы прецедентов, базы знаний. То есть вот в приведенном, кому будет интересно ознакомиться чуточку подробнее, да, то есть с авторским коллективом, который в первую очередь отвечают за методологию анализа среды функционирования, то есть вот эта предшествующая тематика в исследованиях, она указана в работах, и можно будет подробнее, партикулярно тогда обсудить уже.
Окей. Please.
Что так удобнее будет, да. Скажите, пожалуйста, вы говорили, что вы из Роскосмоса, да?
Да. Центр коммуникации.
И у вас, я так понимаю, есть лаборатория, которая этими исследованиями занимается, да? То есть просто...
Это в рамках расширенного авторского коллектива, а конкретно лаборатории как таковой нету, но это действительно в рамках усилий по формированию некоторой профессионально ориентированной социальной сети, но будем говорить все равно на основаниях инициативных.
Ну, не зря Роскосмос — это корпорация. Это, да. Видно, да, может себе позволить. Спасибо.
Спасибо большое.
Окей. Thank you.
Спасибо большое. Да. Thank
you. The next presentation is number 101. Please.
Our work about parameter estimation for arbitrary order Markov modulated
for some process. Thank you. And our main motivation was to develop a new approach to estimate parameters, because the processes with changing parameters are widely used for different applications. And Markovian arrival process is a specific model which describes a lot of applications too. And usually EM algorithm, expectation minimization algorithm, is based on the maximum likelihood method is used, but it has some drawbacks, and the main are the difficulty to distinguish local and global maximum, and the iterative nature of the algorithm, which leads to a lot of calculations. And our problem is we have MMPP process, and we have different intensities, lambda 1 and lambda n, and the time of being in every state is also distributed, has the exponential distribution. And we observe some events, and we analyze the time between these events. And according to the model, we can consider the distribution of this time between events as a mixture of exponential distribution, so as a hyper-exponential distribution. And the problem is to evaluate to estimate all the parameters. We use the method of moments to estimate parameters, and based on the problem with two parameters for this problem, we can get exact estimates written here in the slide. And for the probability, we use the maximal likelihood method. We can use it because the interval is bounded. And then we do the following. We suppose we use the cumulative sum procedure. I cannot explain all the formulas, but the idea is we have two cumulative sums. One of them reacts for the increasing of intensity, and another reacts from the decreasing of intensity. And we define the intervals for every parameter, and then we evaluate the parameter. And if we have n parameters, we do the following. We again construct custom statistics. We use the minimum parameter, and it is known that if you have a lot of intensities, the minimum intensity is estimated quite well. And we construct again the cumulative sum. In fact, we consider the distribution and we cut the tail. And again, we analyze this distribution, and then we estimate the second parameter, lambda 2, then the third, lambda 3, and again we apply this custom procedure. And after -1 steps, we find all the estimates for all parameters. And I can demonstrate you some results. Here we have a process with 3 parameters, and we have intensity parameters, we have certain time parameters, and we have the probability matrix P, which describes the probability to switch from, for example, the first to the second state. And here you can see some simulation results, which allows us to say that we can use this procedure to estimate parameters from to estimate parameters of the process with n rates. Thank you for your attention.
Thank you. Okay, questions, please. No questions.
Thank you.
Thank you. The next, the presentation number 108. Please, speaker is, who will be speaker? Lee Gaufen.
Hello everyone. Today we will introduce the inter-channel attention transformer used for Polish image classification. Synthetic aperture radar image classification refers to process of using image data acquired by remote sensing data to identify and classify targets. Parametric interferometer synthetic aperture radar data increase the information of remote sensing including attractors and luminosity or weather. A deep learning framework based on CNN and local window sense transformer is proposed for pulsar data classification. The interchannel attention matching was introduced to improve the generation ability of characteristics. Experimental results show that the model performs better than exciting methods on polarized interface dataset. This is the architecture of the model we proposed ICAT. It consists of 3 parts: feature extractor, two stack targets, and class detection. Feature extractor model is as shown in the figure with common 3D and common 2D. The 2 stages are stack 0 and stack 1, which are shown in the figure. Each stack has n numbers of local window attention blocks. The main model is attention block, which has encoder and decoder. Encoder consists channel and local attention models. Decoder consists model hand and inter-channel attention models. The most important model is the inter-channel attention, which is shown in the figure. Our attention mechanism is based on the classical self-attention methods. However, we introduce the interaction of channel of SAR, which is cluster informer. We conducted some experiments to test the model. The first data is wavelet. The left figure is the polar RGB of wavelet. As a comparison, the right figure shows our classification results. The second data is San Francisco. The left figure is polar RGB of San Francisco. As a comparison, the right figure shows our classification results. The graph represents the training accuracy serves of 3 datasets of 100 epochs. We can see the feasibility of our proposed model. We should attain high accuracy score. Subsequently, we will conduct more experimental tests and ablation comparison. We proposed the ICAT, a normal model that utilize the interchannel attention relationship of polarized in the ferrometric SAR. It enhances the global feature recognition ability, reduces the training costs, and the experimental results are comparable to those of advanced models. In the future, its efficiency will be further improved through a sparse attention framework. Thank you for your attention.
Thank you very much. Please, questions? Your models have?
Sorry?
How many parameters your models have? Number of parameters of your model. 1 million, 2 million, 3 million of parameters. How many?
2 million. 2 millions.
2 millions, okay, thank you. And on the second slide, you said that your model has accuracy better than state-of-the-art model, but on your slide we don't see any comparison with other approaches. So do you do any comparison of your model with different approaches?
This is the comparison.
No, this is the results. But we see how your model works on this data set, but how the others model work with this data set.
We propose the new model.
Okay, but
use the DNN and the attention relationship.
But is there other models that solve the same task? Okay. Okay, thank you. Okay, thank you for question. Thank you. Please. The next presentation is 111. Please.
Good afternoon, dear colleagues. My name is Igor Krivaltsevich. Today I will talk about practical aspects of FPGA implementation of neural network for image classification based on learn-separable transform. The study aimed to create a resource-efficient hardware architecture for FPGA-based image classification. We focused on NIS dataset, a simple architecture like one-layer perceptron, not sufficient efficient. Adding hidden layers improve efficient, but also increase the number of parameters. We propose to use learn-separable transform. Our neural network architecture is inspired by separable transform, a concept with origins in image filtering. Subtle filter is a well-known example of separable transform. A key feature of separable transform is that reduce the number of parameters from n squared to 2n. Our proposed LST process an image row by row and then column by column. The LST output a feature vector representing the input image. The dimensionality of this embedding is determined by the parameter dout. This diagram will illustrate two main blocks of LST processing. It's the first fully connected layer that operates on the rows, and the second that operates on the columns. The simplest architecture with LST block use one LST block with fully connected layer and softmax output. We refer to this foundational architecture as LST1. For the case of 28 by 28 input and output leads, the model will have just 9,474 parameters. Of course, we can push for a small embedding, but this comes at the expected cost of reduced accuracy. This is the architecture of our neural network. This architecture have two types of processor elements. Also, we have RAM to store image on all steps of image processing, and control unit to control the operation of all units. The first type of processor elements, it's a row column output. The second type, it's a row column. The first type of processor element have output layer ROM that use that store output fully connected layer parameters, and this processor element reuse for finally fully connected layer calculation. We describe in this design in System Verilog and implemented it on the Xilinx Ziba Z7 FPGA board. We use a Linux PinQ distribution and on the ARM core for experiments. We use only 7% of LUTs and 4% of flip-flops of this board. Also, we have more than half of BRAMs and more than 70% of DSP. We use for experiment MNIST dataset, and we train our neural network on 300 epochs. In this slide, you can see image on all steps of LST processing. The final image, the final LST output, it's look like irregular code pattern. We write Python model float point and FPGA fixed point model with 6 bits in integer part and 7 bits in fractional part. We achieved 98% of accuracy at float point model and 97.9% in fixed point model. We compare our model with another architecture. We use 5U parameters and have very high accuracy, 97.9% on FPGA. In conclusion, we propose to use two-dimensional learnable separable transform for compact neural network. It gives high accuracy with a small number of parameters and work efficiently on FPGA. Thank you.
Thank you very much. Okay. Please, questions.
Does the FPGA increase the speed of inference, and do you have any like comparison?
No, we don't compare our architecture by speed parameter. We just compare with number of whites and biases with other architectures.
Thank you. Okay. I will be do the next presentation. My presentation about semantic space and modeling of semantic space. The structure of my presentation. Excuse me. The structure of my presentation consists of six stages. The first stage dedicated with modern contemporary challenges and partial solutions in AI systems. And this slide shows that these challenges perhaps connected with semantic gaps between different language set models which are used to build contemporary AI systems. And semantic gaps perhaps can be eliminated by means of semantic space. The next slide shows approaches to modeling, semantic space modeling, and some names of researchers. And our approach is unification, which aims to eliminate homonyms and synonyms one concept using an unique unified concept to represent each unique meaning from the universe of voice meaning. Formally, this approach can describe it as this slide shows. And what is important that we should consider stable features of semantic space, topological and metric features. The next slides illustrates that if we deal with static ontology structures, we have usually a finite one, and all structures are based on finite fragments. There are several kinds of such structures, and there is ontology of. We can build topological and metric space on such structures, and we need to perform 3 stages to do this. The next slide illustrates the specificity of analyzing dynamics in ontological structures, which can be described with the finite state transition graphs. And this slide shows the entropy measure which can be evaluated to compare such structures. And what was one of the problems that some structures which is not strong connected can be analyzed with a similar measure. And the next slide deals with network models. The main question is that in network models we use classical mathematics with permanent numbers, classical, but computer deals with temporal structures, and in this job, the model of proto-multiversal numbers proposed, which take in account takes in account temporary nature of evaluations and topological features, and this allow us to define the semantics and denotations for science, which can be recognized in such tasks. It is summary, and thank you very much. Okay. If you have questions, please.
So please tell if you analyzed a real, not very big semantic spaces using the metrics that you proposed, or all example is a model example.
It is task for following research because it is some analysis was done, but it is not for serious results. It will be more job.
Thank you.
Okay. I will ask to present next speaker. Okay.
Dear colleagues, good evening. In the framework of our research, we used the data in the form of so-called input data tables compiled by researchers from the School of Applied Economics at Zhenmin University of China. And these tables are not high-dimensional data, are not big data, but still they is a traditional tool of economic modeling and give us a rather systemic but simplistic but still systemic picture of the evolution of Chinese economy during almost 4 decades, 40 years. Our data analysis pipeline was rather simple and straightforward. We transformed data from the raw data in Excel format to R data format. We calculated a lot of economic indicators. I skip details now, of course. We use sectoral aggregation of resource inputs in 4 broad categories: primary resources like agricultural products, etc. Secondary resources, it is like machines, equipment, computers, tertiary resources like IT services, R&D services, etc., and also capital and labor inputs. We used several visualization techniques, and finally we made time series clustering. And some results briefly. For example, here we can see 9 sectors of Chinese economy and the dynamic of input shares at each sector of Chinese economy in those broad categories I told you before. And here we have, it can be seen like, technological recipes in broad categories of each sector of Chinese economy during these 4 decades, for agriculture, for mining and quarrying, for machinery and equipment, etc. And again, also 9 other sectors, so we have 18 sectors, economic sectors of Chinese economy, and evolution of resource inputs shares in these sectors. Even if we simply look at the charts, we can find some similarities, some maybe even patterns. And here you can see, for example, 4, 4, 4, or for example, 2, 2, and 2. And of course, because of lack of time, I just want to say that, of course, we should bear in mind that these data is in current prices, nominal prices, so with inflation, and we in future it is better, of course, it is rational to use constant prices. And finally, we not only look at the charts, we use some approach to make time series clustering, dynamic time warping approach. We used implementation in our language. We used different distance metrics. We trying to find optimal number of clusters with different approaches, different centroid calculation methods, and so on. And one of the results here, we can see 4 clusters for consumption of inputs from tertiary economic sector services by each of 18 Chinese economy sectors. To the right, you can see the list of these clusters and sectors divided by these clusters, and also you can find the conditional, I would say, fancy or funny names of these patterns, slow growth, for example, or big from the start. And conclusions, of course, for one country, for one national economy, even for such a big country as China, maybe data mining approaches cannot fully show their potential, but because of growing number of rather big databases for global economy, we are optimistic that this untraditional method for economic analysis will be very fruitful. Thank you very much.
Thank you very much. Okay, please ask questions. Okay.
Okay, yeah. Thank you very much.
Thank you for an interesting report and presentation. Tell us, please, how do you think inflation will influence on results?
Unfortunately, for this research, we did not have data at constant prices. Now we have it, but we do not still have results, so I cannot answer. Supposedly, inflation, of course, makes some distortions, but because we analyzed ratios, so not absolute numbers, but ratios, maybe it is not, this effect, distortion effect, is not as big as we can expect. But results at constant prices, unfortunately, we do not have already.
Okay, thank you. And second question, please. Would you tell us how you are using dynamic time warping for economic data? It's very interesting.
Yeah. To tell the truth, because the team of this research, everybody are economists. For us, it's rather new and maybe even a little bit unknown tool. So we just have this engineering approach. We have package, we have some manual of it, and we use and have some results. Maybe in future we will find some nuances which maybe we should think over and change in the future, but we just put inside time series for each of 18 sectors for China economy, and we ask the method to find similarities and group similar dynamics, sectors with similar dynamics in one group or another.
Okay.
So something like this, yeah.
Thank you. I see. Thank you.
Thank you.
Thank you very much again. And the final presentation, number 40, Kurочка Konstantin, Panarin Konstantin, Karpenko Denis.
Good evening, my name is Konstantin Panarin, and today I'll be presenting our work on resource-efficient optimization for real-time safety monitoring in industrial environment. Ensuring worker safety in high-risk industries like oil and gas is a top priority. While automated computer vision systems are powerful, they typically demand expensive GPU hardware. This is a major barrier for many industrial sites, which often limited and only standard CPU-based computers used. Our research addresses this critical gap. How can we run accurate real-time safety monitoring on existing resource-constrained hardware? Our solution is a CPU-optimized processing pipeline that intelligently reduces the computational load. Instead of analyzing every pixel in every frame with heavy model, we do it in 3 smart steps. First, using Gaussian mixture models, we subtract the static background, instantly filtering out irrelevant information. Second, a very fast and lightweight model, UIIP Nano, scans the frame to find the general location of the person. Finally, a more accurate and powerful model, UIIP Small, performs a detailed analysis for things like helmets and vests, but only on that small predefined region. This focus of attention strategy saves an enormous amount on processing power. To validate our approach, we created a robust dataset using over 8 hours of real-world video from active drilling rigs. Crucially, all of our experiments were conducted on standard Intel Core i7 CPU with no dedicated graphic cards. We compare 3 configurations: a baseline using a standard YOLO model, our 2-stage row cropping method, and our full pipeline, which includes background subtraction. The results speak themselves. As you can see in the chart on the left, the baseline system was too slow for real-time use, achieving only near 8 frames per second. Our full optimized pipelines reached over 24 frames per second, and nearly 3-fold increases in speeds. And about accuracy, the chart on the right shows that we didn't sacrifice quality for speed. In fact, our method slightly improved the mean average precision. We achieve a massive performance gain while keeping system reliable. In conclusion, our methodology successfully increased the processing speed by near 3 times, making the real-time safety violation detection and practical reality on standard CPU. This work demonstrates that intelligent algorithm optimization is a powerful alternative to expensive hardware upgrades, opening the door for a wider and more affordable options of smart safety system across the industry. Thank you for your attention.
Thank you. Does it work good with multiple people in the same frame?
Yes, it slightly reduces the frame per second, but it works for multiple people.
Okay. Good evening, friends. Good evening, colleagues. Again, my name is Evgeny Volsky. I'm chief IT manager of our Belarusian state-owned petroleum Belarusneft. Konstantin is my colleague, and I know this project because I have some questions for him. I'll try to. Okay. How does the quality of video materials affect system preparation? That's a double question. And how much video materials is required to prepare models?
Actually, to train this model, around 30 minutes of video enough if all 30 minutes consist people in our safety equipment. And quality of video, it can work with about 48p, but for good results, probably we need HD video.
Okay. Second question, what are the minimum computing resources available to you for running the system at the real drilling objects of our company?
It can run on CPU, as we say in our report, on Core i7 10700 is more than enough, so probably any actual modern CPU is enough. But if we use any even cheap NVIDIA GPU, it will be way more faster because it can use CUDA.
I tell some words. We have a big limitation of our digital resources in our drilling station because it need to, the service will need to have a special industrial explosion-proof design. It is very explosive, of course. That's the first point. The second point, we can give a good internet, good connection to our drilling stations because usually they're placed in very remote places, sometimes wild places. And it can have to good connection with our data centers and use big digital resources. And it's good place for this project too.
Thank you for your clarification. We are ready to declare our session closed, finished. Thank you, all participants.
Thank you, the chairman. So for this, last but not least session during this day, and as a conference manager, I'd like to thank all of you. You are very brave because it's really late now. And actually, so I just as an announcement for the next day. So it will be the last, again, and not least day, but the last one, which will be also very important because in the morning we will have a very quite famous people from National University of Defense Technologies in Changsha, so Hunan province. Then we will have online session with Changsha. So it is our partner, which a co-organizer of the conference, and then they will, during the lunch, we will have a hackathon session. I mean that results of the hackathon, which was provided by Defense University. So we will see during the lunch some results of what they do with drones and target recognition. And at last, so we'll have a closing session and ceremony of celebration of winners of lightning talks. Thank you all. So good night, and I would love to see you all tomorrow morning. Thank you.
"17 conferences, 34 years of history. More than 1,300 warts. More than 4,000 participants. Innovative trends. Meetings of ideas. And more. Pattern recognition and information processing. Embedding the future.